Hello. Ah, there we go. Alrighty. Now let's do a share. Paste that in there.
Select the unit. There we go.
All right. If you notice, I have earbuds in. Making everybody sound horrible because they're like really cheap earbuds, the kind that you get on airplanes. Now they just hand them out so you can watch the little screen and be pacified for the flight. So my own voice sounds really weird too. So if this stream is weird, then you know why. But it's funny. I put them in, and immediately it sounds like I'm in an airplane because it's exactly like what you hear when you're in an airplane. But I have stitches in this ear right here. It's really hard to see, but they are there. I went to the doctor on Monday, and there's a spot on the back of my ear that was showing all the bad signs, all the signs you don't want a spot to show. And it was having them. So I went in, and she took a punch out of it, to basically do a test, whatever test they do. I don't know. I don't know what goes on, but I go back in next Monday to get the stitches out. And it was weird, she didn't take that much out of my ear. At least she didn't say she did. And then she put like 1 or 2 stitches in my ear. I'm like, the amount that you said you took out was like the equivalent of a paper cut. Why do I need stitches? Why can't you just like super glue that shit or super glue it closed or something? I don't know. But anyway, yeah. And it may end up I have to go in to get more removed, right? It's like, I don't know. Anyway, that's just a saga. Whatever. So that's why I'm not wearing headphones. I don't want the headphones going over that area, even though my over-the-ear headphones, they don't really hit it, but I have to wash it a couple times a day, and I have to put this like ultra pure Vaseline on it. She gave me this little tube of like ultra pure, I don't know, medical grade Vaseline, which was just kind of funny. I was like, I got plenty of that at home. Not medical grade, but anyway, we are going to continue our pipes today, even though my voice sounds really weird. I've worked a little bit on this since the last stream, and I've mainly been working on mod development for EU5. I did all of last Saturday's stream working on a mod, and that's out and uploaded, and even put out a few bug fix patches fixing various things with it that I find when I test. It's hard to test anything in that game because everything takes so long to get to and to test. But yeah, all the bits and pieces are working now, as well as some updates for my cabinet action mod. So the actual game I'm playing I'm playing as England now and testing stuff out there, and yeah, the game has a funny RNG. That's for sure. It's not RNG. It's not random. It's just pseudo random, right? Events and stuff. As often as your super awesome heir dies, which happens a lot, it's not random. Anyway,
Perhaps that's part of it. That since your character is so awesome, that somebody has to take him out and
right.
assassination.
It's like the better the character, the more likely they are to die in a hunting accident. It's like, yeah, okay, that's not random. I mean, I get it. At least allude to the fact that it was not an accident, and let the actual king, let the ruler, right, come down on whoever it was and seek justice, and actually treat it as you would treat it, right? If you're a king of a country and your 15-year-old heir goes out on a hunting trip, right, and ends up dead on that hunting trip, you are executing everybody on that hunting trip, right? Because you don't know who did it, right? So you are just, everybody goes, everybody, take everybody out. I don't care, right? Your job was to protect the heir, and he ends up dead. Like, I'm sorry, but the other side of the coin of that event happening should be the choice: execute them all. That should be the choice in the game, and kind of show people, hey, this shit isn't tolerated. Like, everybody goes. Or not. I don't know. Maybe it was an heir that you didn't like. I mean, there are some times that you don't want the slow heir. You want the spare. So maybe there's a choice to say, hey, maybe there's a hunting accident on this trip. But just to have it happen.
Maybe you're the one that instigates the
right. And that's like a large part of like CK2 or CK3 has that too. There's a lot more of that sort of BS, in like day-to-day kingdom action. Is, in CK3 you can actually like take out a wife and then marry somebody else, very much like Henry VIII style. Just be like, I need a wife that gives me a son, and you just keep going through them, and it's like, it's not the wife's fault, but it doesn't matter. Why do you think Henry VIII went through so many wives? Anyway, now, so yeah, the game is engaging, but at the same time frustrating. It's just one of those games. It ropes you in. I was even playing last night till, I don't know, what was it, 3 a.m, something like that, 3:30. And I'm super overpowered. Like, I am England and beating the crap out of France. I already own a quarter of France's territory as England, and it's like the 1370s. Like, I'm just beating them up right and left. It's kind of fun, justice for my ancestors. Although most of my ancestors are Irish, Norwegian, so it's, whatever.
So you should be getting revenge against England.
Yeah, I should be not playing as England. I should be playing as the Irish, beating up England with my super soldiers. Which, I mean, that'd be a fun campaign. Play as Ireland and just start dominating that area. But yeah, it was funny, the very first 100 Years' War, the very first war that broke out between me and France. France was starting, like, the amount of troops that they're actually able to bring to bear is astounding. But with my between my cabinet actions mod and my rebalance mod, most of the buffs, like the vast majority of the buffs, the player gets, right? The AIs don't. And so I was able to turn that around and eventually get enough war score against France to take Paris. Actually, I took Paris from under them, right? Because I wanted the trade node. I took Paris and then built my governor in Paris. Oh, it was great. It was so great. And ever since, every war that we've had since, I have taken more and more territory. So now I own roughly the top quarter of France. It's all mine, and it's all English. I've converted everybody. They've all seen the light. Okay.
One way or the other.
Yeah. Now we have this lovely thing here. Okay, yes. We have I'm just trying to get my bearing where I left off. So update tick, yeah. So continuing this on from where we were before, Cat, even with my earbuds in, I can still hear the purrs. Aggressive purrs. Okay, we have I'm trying to gracefully excise the stuff out of here. Item transport, yeah, see transport handler. This is kind of the meat and potatoes of the system. What I need to do also is strip out from the old objects. I need to strip out any events, any ticking. Like when you load your world, it should load it, but not like all your old pipes. It should load them without any crazy crashes or anything. And basically just not do anything, right? It's not going to extract it. They're just going to load and just stay quiet. Which will allow you to come in and break them, and translate them to the new pipes. I can even make it so when you break the old pipes, they drop the new pipes. Right? I can control what block gets dropped when you break it, and I can make it say, "Hey, drop the new pipe." That way, people don't even have to translate the blocks when they break them. They have to do that. They'll have to do that with any that they have sitting around in a chest, right? If you've got a bunch of pipe, you can just translate it over. But anyway, we have. Before I do that, though, I would like to get the basics done. Let's see. What kind of algorithm are we going to need? Because we have this build insert node list algorithm here. Let's see. we are going to need one that rebuild pipe graph. Okay. So okay, I did write this. I don't remember writing this, but this manages E-pipe insert sides. If overridden sides. Okay. This, if it's not overridden, check the direction. If it's a pipe, add it to the list if it is not contained yet. I want to make sure if to add dot contains con direction continue. Well, we don't want to do a continue, I don't think. Yeah, I don't think we want to do a continue here. We do want to add it if it's not already added. And this is one of those edge case situations that you have to sort of think about. If you have a pipe that's wrapped around a machine, let's say a pipe goes out, over, and back, and it's three sides of the machine are connected with this pipe, is that three separate insert nodes that we should manage? But as far as checking connections, right? We do want to look at the insert side. So this we want to do. But if the to add contains the direction, or if it doesn't contain it, we want to add it. Right. So we don't want to add it. And again, this kind of takes, if a pipe, if you have a snarled mass of pipe where there's a whole bunch of them all connected like in a ball, well, one pipe is going to connect to another pipe all over this, and you might be adding the same pipe over and over and over and over and over again because you're traversing the list. And it's like, no. We want to just add a single instance of a new pipe to check. This is just checking the pipes. This down here checks the sides. So we just want to do this. We do a continue here only if we've already checked it. Right? If we've already checked it, we want to continue because we don't need to check it again. Or if it's overridden, we don't need to do anything if it's overridden, and that includes insert nodes. The direction into a machine can be overridden as well. So if the side is overridden, we don't even want to look in that direction. We don't care. And then if it passes all of these, then we check all of the sides, insertion and extraction. I don't know why I do this. If extraction nodes that contains position. Like, okay. So this while loop here, when this finishes, after all of this is done, we will have two main lists. We'll have all of the positions of all the extraction nodes, and then we'll have a list of all the insert nodes in the whole network. Then we iterate through that list of all of the positions of the extraction nodes, and we basically mark dirty the node or the extraction node itself, and we pass it a list of all the insert nodes. And I think what I ran into, if I remember right, and this is my memory doing its thing, what I was running into was the insert node list was being passed by reference, which is a problem, right? That's a problem because every extraction node needs that list and an independent copy of that list because it's gonna sort and iterate through it all on its own. So it's like, yeah. So pair.value, which is the extraction node, mark node dirty, which is getting the insert nodes. Then I clear the lists, right? And this is why when you pass something by reference, and then you go through here and like clear it. Well, these are all passed by reference. So clearing this list could easily clear all of the all of these. And so I believe what I did was in the mark node dirty, yeah, I basically iterate and I knew it while I'm encoding the distance, right? So I'm creating a new list in the call, and I'm calculating distances from whatever this extraction node. This is an extraction node. So from my perspective, I get this node list of all these different positions, and then I calculate what my distances are from my perspective, creating a new list from it, and then my nodes, like this node list here, I can now ignore. I don't need, if this can be cleared after the call, and it doesn't matter because I've already created this, and I need to do a position.copy here. Because again, block position is a reference thing. So, that goes into unsorted nodes. Which here, and then I need to sort the list. Is dirty equals true. Is dirty equals true. And then there's the call in here. That's the initialize. Where is it at? Zooming around the place. All right, I've got to be careful with this call now. Because this call now will rebuild the list. And all this did is apply an upgrade. So this did not change the node at all. So the mark no dirty sets me dirty, but it also, right, it also tries to grab the nodes, which what I could do here is add a Boolean into this call here that is basically like rebuild node list, true or false, to control this. Because this is, we want to be careful because this is a call that, if done enough times with enough frequency, could bring down and cause performance problems, right? So we want to be careful with how often we do this. So if we do like bool rebuild node list here, and then if we do if rebuild node list, right? Luce, what are you doing? Huh? You're tear-assing around here, and then you come over here. What usually is, right? If she gets into something that she's not supposed to get into, or she knows is like bad while she's playing, she'll come over here and get into my lap and be all lovey-dovey for 5 minutes, right? And then she'll leave. But it's her like, oh man, I know I got into something bad, but here I am. Like I'm not doing anything, right? You don't see me being bad, so it's just her like softening me up for some eventual discovery after I stream. I'm like, what?
She's racking up some affection points so that you
100%. It's just it's crazy. Like, really? If unsorted, I need to do this. Unsorted nodes does not equal null, and I need to check the null state, because this, right? This can be null on this line, because this build insert null list is returning a list, right? So this is returning a list. And this call is usually creating a new list, right? It creates a new list, fills the list, and then it returns the list. So this now has the list. This thing can return and doesn't care, right? It's, even though the list that it creates is out of scope, the API.NET is smart enough to know that this now has the address, right? The array or the list that was in memory there is an object that has that memory address, so it doesn't garbage collect it, right? But if we gave that list to anybody else and they did something with it, this is going to reflect that. Like if I had another pipe extraction node that had that same exact list, sort of like what we do down here, and then the other extraction node sorts it ascending, but I need it sorted descending. When that other extraction node sorts it ascending, this one would be also sorted ascending. And then if I sort it descending, the other extraction node would also have it sorted descending. So it's like you need to be aware of how these objects are being passed, because you could easily run into the situation. And then bugs like that are really insidious and hard to track down if you don't know what you're looking for. Because a bug like that, if one node wants it sorted descending and one node wants it sorted ascending, they both have the list and they both are extracting and inserting things. But the behavior, right, the items being moved around, it's not causing a crash, it's not generating errors, it's moving stuff around, but it's just one of the nodes is not moving them in the right way. And so you're like looking at this going, how the hell is this happening? Why is this sorted the wrong way? And then, you it can take hours to track a bug like that down because you don't initially know to look for how the array is being used or passed in memory. And it's just, yeah. Like bugs that don't cause crashes are some of the most insidious bugs out there. They're crazy. All right, so which is why like a lot of developers, they'll actually add a crash. They'll add an exception into their code that says like exception if this happens, and then you'll have people crash on that, and it gives you more information. Like I could do that, but people would be crashing all the time because of weird edge cases, and I don't want that. Okay, so mark node dirty if rebuild node list. So then we come back down here and we just set this to false, right? This, now we apply the upgrade. This processes it. Updates itself, but doesn't necessarily need a complete rebuild of its own systems. It marks it dirty, so it's is dirty equals true, and then we pick that is dirty up down here. So this is the call, right? That when it is dirty, we need to basically resort the list. Let me minimize some of these here that I don't need. So unsorted nodes. Yeah, unsorted nodes we need to check. So down here, if unsorted nodes does not equal null and unsorted nodes dot count is greater than 0. Okay. Insert nodes equals unsorted nodes dot sort. this is going to be largely based on um, push. Yeah. Um, unsorted nodes equals null, or unsorted nodes dot count equals 0. Um, yeah, this is rebuilding it anyway. So no matter what we do, we mark it as dirty, it's going to rebuild it no matter what. So what I think I need to do is just remove this call, because this apply upgrade doesn't really affect the insert nodes at all, right? It affects the tick listener, it affects the extraction ticks, because different upgrades tick at different rates, and it doesn't really affect it doesn't affect the number of things in the insert nodes, right? It will affect what insert nodes we look at, especially when we implement basically the subnet system, which will allow you to filter an extraction node by some value, and then it'll only look at insert nodes of that same value that have that same subnet on them. So I think here we have this, and we don't need to mark this dirty at all. We really don't. Now that I'm into the weeds on this, marking this thing dirty, well, let's see how many other places. Disconnected size. Why is this? What? BE pipe base. Oh. Yes, network IDs. More stuff to remove. Now, did I? Yeah, I changed that. Block facing. That's fine. Network ID. Disconnected signs? Is this one of those that's BE pipe base new does not contain a definition? I'm pretty sure it does. What? Overridden signs? What? Disconnected sides. Overridden sides. Okay, that's why. I changed. I changed what it was called to overridden sides. It's a little bit more. That's weird that I changed the name of that and it changed it in a bunch of places, but then it missed a bunch of places. Right? I have overridden sides right here, but for some reason this one didn't change. Yeah, we are definitely going to be excising all the network-based stuff out of here. Okay. Rebuild pipe graph. Okay, this and this. Rebuild shape should be largely unchanged. Where was I working on? Yeah, there's a lot of process. When you right-click a pipe, there's a lot of code that's run to determine what the hell you want to do. there's a lot of things that change. And yeah, we're not done yet. Okay. We want to go clean with soap. That was here. Reset enumerator. What? No overload from method. Takes one argument. Okay, then why was I able to make this call in the first place? Reset enumerator. Pipe extraction node. Reset enumerator. Where is reset enumerator? What? Extraction nodes. Oh, I'm in the wrong object. Pipe extraction node. Did I temporarily remove a bunch of code out of here? Why? Push connection. I'm not understanding how. That's weird. Huh. I don't understand why some of these calls were passing something in. Huh. Hey, Robert. Okay, so the clean, we got to get back to the clean. Okay, so this, right? If unsorted nodes equals null or unsorted nodes.count equals 0, grab the new list, right? Push enumerator, we clear it because we're going to edit. We're going to edit the list, right? We're editing the insert nodes, so we have to dispose that enumerator if we have it. And then we grab insert nodes. If insert nodes.count is greater than 0, well, you need to also add if insert nodes does not equal null, and that if unsorted nodes.count is greater than 0. I'm doing okay. Hanging in there. How are you doing? Okay, unsorted nodes.count. So then we process, right? We process the list. So if our distribution mode is in farthest first, we order by descending, right? In hospital. Oh man, dude. That's not cool. Hope everything's okay. So we're farthest first, order by descending. Any other mode is order ascending, which is this. Order by. We're just giving it the element to sort by, which is the distance. They're unsorted, but they should have the distance encoded in it. And we can validate that. Right. The unsorted nodes here, we are going to need this to encode distance, I believe, if it doesn't already. Foot and oh Jesus, that's not good. So we have this order by, and now insert nodes has been refreshed, right? Is dirty equals false. Come back up here. Clean with soap. And then what we're going to do is return. We're not going to process the tick. We're not going to process a transport operation. Right? I mean, what we can do after this clean with soap is if pipe distribution equals round robin reset, or maybe get push enumerator. Well, do I want to just insert nodes, get enumerator? Yeah. And we can just do push enumerator equals insert get enumerator. Like that. If we're in round robin mode, we're going to need the enumerator. So after we reset everything and resorted them, then grab the enumerator, but only if we're in round robin mode. Right, and then isDirty equals false, comes back up here, and then just returns out of here. So the isDirty call will skip the actual transport tick because this call will consume, a bit of CPU cycles, right? So doing the transport tick on top of that, I think is just too much. In a single tick, right, which should not take very long, in a single tick, it's going to consume one tick when you mark it dirty. Okay. Now, let's figure out our errors here. No overload for resetting. Why do I have if or for does not equal null? Extraction nodes. What are we in? Dot reset enumerator. What call is this? Alter push connections. I must have had this. What in the world? Block entity pipe base. Pipe connection. So this is the old object, right? And again, I want to just make sure that this can load, but really nothing else. Like, we don't want to do anything major in this function or in this object anymore. It's like, especially not any of this move. So we're going to go to the initialize here. And we're going to say, hey, I think we still need to run initialize on the extraction nodes. Unfortunately, I don't know if there's a way around. I don't think there's a way around that. But mark pipe dirty, we don't want. We don't want this or this. Right? Or that. or any of this. Literally, like, initialize everything, initialize it, and then I'll look at this here, which is pipe extraction node, initialize, and then let's go here. Because I need to initialize the old one, which is still going to be a pipe extraction node. So it's going to be the same object. The extraction node is not changing. But so we have to initialize it, which initializes the inventory, because when somebody breaks the block, we need to be able to drop all of its contents properly, right? This is still valid. This is where, when I added the feature where you can go into a config and say, hey, don't do pipe ticking, this is what catches that, right? So apply upgrade. If API does not equal null, what I need to do is not I don't want to apply upgrade if the position of this node. So if api.world.blockAccessor.get block at position is block pipe base new. And I'll have a call. I'll have this call in here for a couple versions. I'll probably forget about it, of course. But I'll eventually take this call out. And I'll take the call out when I wholeheartedly remove the old objects from the mod. Which, again, will be a couple versions. It'll give people plenty of time to remove all of their old shit, which wouldn't work anyway, right? The old pipes are not going to actually move anything, right? So if you got a bunch of pipes in your base, once this update comes out, if you got a bunch of pipes in your base that aren't actually moving anything, it might be time to break and replace them because they're the wrong thing. Now we have if API doesn't equal null, if API.world.blockAccessor.getBlock at position is block pipe base new, then apply the upgrade. Right? Otherwise, don't do it. We don't need to apply the upgrade. The apply upgrade is the thing that creates the tick events. It's the thing that creates the enumerators. It's a lot of stuff that we don't need to do if we're on the for the new system. We only want to do that if it's a new one. If it's an old one, don't do it. And then this is checking, right, the do network tick thing. Okay, so Yeah, here's the apply upgrade. This is we don't want the old one to call the new one because we're referencing the new one here. So this would not be good. You don't want to do that. But all this does is sort of set everything up to start extracting, which we're not doing with the old system. So we don't need to worry about it. Okay, and then we want we have some update ticks here. Is dirty, clean. I mean, I think this is ready to go here. So we're going to go back. This is the old system, which this is alter push connections, which I think is only called with the pipe network, which is literally we're going to basically remove it completely. So network ID, so this is the new one. We need to excise pipe network information here. But I kind of want to leave these in for now because this is very, very, I need to be very careful. What is this? Cannot implicitly convert type. Right. And again, this is an old system. Right? We changed what the list is holding, right? Push connections. We changed what it is from pipe connection to pipe insert node. Push enumerator, yeah. So we don't need this at all. Really? It's not nullable. Okay. How about we just not do the thing at all? How about that? Again, this is the old object we're not worried about. So now we have the three references in network ID. So now we're at a point of scrubbing the network completely out of the mod. So we're going to go to pipe network manager. On game save. I want to make sure we load. Maybe. Do we even need to care about this? Okay. Hmm. I need to take a quick bio break. I'll be right back. Okay. Now, so what I think I'm going to do, we are going to serialize the stupidest number in existence. So when you save it, it's going to save that ID, save a zeroed out amount of data, because there's no like delete, right? There's no like delete this from the list. Oh, delete this from the data. I looked. Right, there's no delete. So save the number. A long is a long. It is what it is. I think I have to do that. Because it's a long. It was a long going in, so I have to make sure it's a long here. And then save the networks as just an empty byte array. And then here, what we're going to do is we're going to load the ID first. And if, well, damn it. Of course, I just get the bytes and I don't deserialize it into the actual ID. So we have to go to the initialize manager. Okay. Pipe networks, pipe, there it is. Right? If next ID does not equal null, next network ID deserialize. Right? So now, if next network ID does not equal negative, right? If it's not like, so basically the first time somebody loads the world, all of this stuff gets initialized in red, right? The next network ID could be 35. It could be 42. It could be, 120, depending on how many times they've built and made pipe networks. That number just keeps racking up. But when they get this version of the mod, the very next time that it saves, right, when you exit the world or you reboot the server, when it saves that to disk, it's going to save a 0-byte array for the networks. So it's going to zero that out, and then it's going to save that crazy, stupid negative number as the ID, which is the indicator of we're moving on, right? So the first time they load it, it won't be that ID, but the next time they load it, it will, and it should just skip. It should just skip the process of essentially deserializing it. Okay. Now, should I instead do a... I'm thinking... Yeah, the entire pipe network manager is gonna go bye-bye. So it's most of this code is gonna be scrapped. Even the debug commands. There will be no network to actually validate at all. The network, the idea of a network is going bye-bye. So it's just would cause too many problems. It's just massive amount of problems. So yeah, this is fine. Save, there it is, on save. I think I need an empty array. I don't know how that saves. So we're going to do new byte of 1. It's going to take a byte. Because an empty array, like how does it write that? A zero length array, there's nothing to write. So how does it know what to read? Or what does it put in that data spot, right? If it's length of 0, what is there? I'd rather have a new byte sitting there. Okay, so on save game loaded. Next action, so we grab the things, right? Now remember, the second time around, this will be a 1 byte nothingness, right? But it's still going to return something. That's why I needed that to return something. It'll just be a blank 1 byte. This will have whatever, 8. This is an 8 byte. So at most, it's going to drop this down to saving 9 bytes. At least for a while, until I completely remove it. Once I completely remove it, and I know that the new system is in place and working, and enough time has passed that gave everybody a chance to upgrade, then I'll just remove it altogether. Then any new worlds created won't even have these listing in there. It won't matter. It's 9 bytes. You're not gonna worlds in this game are gigabytes, right? You're not gonna be missing 9 bytes. Okay. So yeah, get network. On player right click. Again, a lot of this stuff we're not even going to need anymore. Like all I want you to be able to do with the old pipes is break them. I don't want you to interact at all with this kind of stuff. Unless it's to break the block. I don't want you messing with the sides. I want you messing with the connections. I don't want any of that with the old pipes. So yeah, I'm gonna have to be very, very careful. Doing that like this, right? On player right click. We want to remove the network manager completely from all of this. So we don't want to do any of this. This is the old pipe base, right? So none of this stuff we want. We don't really want any of this stuff, but it's hard to just blanketly clear code without knowing exactly what I'm clearing. But let's focus a little bit more on getting at least the new stuff working. So the new block entity, let's go through this. Mark pipe dirty. Rebuild the connection directions. This is one of those functions that causes bugs. One of the bugs reported was between pipes on a chunk boundary, on either side of a chunk boundary, forget that they're the overruled disconnected sides. When you're overriding a side, it forgets and it reconnects itself. That's one of the bugs that's reported, and this is the kind of call that causes that. Is when you have a chunk loaded with a bunch of pipes in it, the pipes in the direction of the other pipes, right, on the boundary, see that chunk is not loaded, right? So they kind of reset their internals a little bit. And then when when the neighboring chunk loads, that neighboring chunk, those pipes load in on the boundary, and in sort of a dance, they look at the pipes that are next to them, and they're like, "Hey, we have pipes next to it. We should connect." Well, the way that this connect, like when you disconnect a side between two pipes, you disconnect the side on pipe A. Well, that calls pipe B and says, "Hey, overrule this side." Because remember, there's two nodes. There's a node on pipe A and a node on pipe B. And those nodes, like if you overrule this one would still exist. So this pipe has to tell that pipe, "Hey, this phase, remove." Right? And so it removes it. But when the chunks load awkwardly, you'll have this chunk loaded in, and it'll see this chunk is not loaded, so it'll just sit here. And if it resets this flag, the disconnected or overridden side, if it resets this flag, which it shouldn't do, that's the bug. If the overridden side, I should never ignore the overridden side flag, right? The resetting that flag is not good. But this chunk loads in, this flag is basically reset because this chunk isn't loaded in yet. Then this chunk loads in, this flag looks at this flag and says, "Oh, this overridden it's not set, therefore connect." And that's where the bug is it's scrambling what is overridden, and one is looking at the other, and it's just. So if that override flag is set, do not reset it. That's the big issue, is that for some reason that flag gets reset somewhere. And even if the chunk is not loaded, do not override that flag. And I think that would solve a lot. But having to do that, there's another bug. When you have an extraction node, that is that phase, right? This over here, this connection, instead of being an insert, it's actually an extraction node. So the block that's extracting from, if this is in a different chunk, this extraction node can't do anything because it can't extract anything because this block is basically null. It's in an unloaded chunk. So this extraction node to be like, "Hey, I'm supposed to be connected to this block here, but it's null. It doesn't exist, right?" And so that can cause, unless you actually detect that and you treat it gracefully, it can cause major problems because you're trying to extract from a null, basically from a null block, which is bad. You don't want to do that. Okay, so Pipe Network Manager, we want to take that out completely, right? Any references to the Pipe Network Manager, that's like the blanket thing we do. Okay. So that really tells me like where all my calls needed, because that just immediately added a bunch more errors. Because a lot of this logic is fine. So mark pipe dirty, rebuild the connection directions. When a neighbor block changes. Yeah, there's 6 references to this. Good lord. So the new system, the system that we're going for here. I'm trying to finish my coffee so I can get rid of it. It's going to completely change the whole marking pipe dirty thing. Okay. So let's start at the beginning. Block. When you place a block, on block interact, neighbor block changed. Yeah, see this. BE pipe base new. Mark pipe dirty. And then on block placed, mark pipe dirty. So what this does is this is the call that marks the pipe dirty. Rebuild the connection directions when a neighbor block changes. So on neighbor block change, swap or mark dirty. And then on block placed. So a newly placed block, also mark it dirty. So this call is a very important call. And then we probably, somewhere in here, we'd also detect, maybe we detect the interaction, right? Because this is where on player right click. So on player right click probably maybe call it again. So we can look at that. But on block broken, we need to call the on block broken of the pipe. Okay. There's no to do here. It's just the get drops are already grabs all the drops when you break a block. It's a built-in thing. So we want to look on block broken. We want to look at too, but we want to look at the mark pipe dirty. So this has 6 references. Dirty shape. So this is the call. It's funny. This is actually what we were just looking at. When I was like, we need to start at the beginning. This is the very call that I was on when I said that, to go back to the block, and here we are right back to the very same thing. So what the big difference is when now that we're excising the network, basically what it's coming down to is if the block changes, which means it's a oh man. Mark pipe dirty. I might need 2 different calls. I need to differentiate a neighbor block change to an on block placed, right? I have to be able to differentiate those two, because the way that I handle each of those events is very, very different. So, mark pipe dirty. What is this called? This is in initialize. See, this is why. This is called when you initialize the block. So when it loads from disk, right, it's being initialized. The problem is that is what kind of makes it forget its connections. Because it's when it's loading, when the chunk loads up, it's marking it dirty as if a neighbor block or something changed. And then it's looking at neighbor blocks and going, oh, there's a pipe over there. I need to connect to it, even though it's being initialized. So by trying to have a single function that does A, the initialization when it's loaded from disk, B, when a neighbor block changes, or C, when you place a new one, the same function is called. Those are wildly different ways of like what you need to do to the data that's inside of it. And I think that was in my efforts to be efficient actually caused the bugs, right? I wanted to be super efficient and have like one function to rule them all, and in the end, it caused more bugs than I needed to. So. On block broken. We also need to do something here. Right? Because this, there's more to it now for a block break event. Because we could be severing a network, we could be, so bottom line, what we're changing to, right? The old way had a network. All pipes, when you would place a pipe and and the pipe would look at its neighbors and be like, oh, there's a neighbor block that has a pipe ID, right? A network ID. I'm gonna become part of their network. And the network was trying to manage all of this data constantly, especially when people were like building onto the pipe network in different places and blah, 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 blah. Like, it was trying to manage all of that data and trying to keep it all like locked down. Well, the more moving parts you had, especially if more than one person was like building a pipe network on a multiplayer server, you had the thing trying to manage the network. And eventually something would go wrong. There would be an invalid pipe. There would be a block entity that would be bad or something, and it would just foobar the whole network. Because once you had an invalid block entity, which also could come from chunk boundaries and stuff like that, right? You would have this null block entity, and then that would basically percolate through the whole system, and it just was bad. So the whole network ID, or the network idea was like you have one object that all of the extraction nodes can look at. Like, hey, what are the insertion nodes, right? And the actual pipe network would have sort of a list of all the block positions for all of the insert nodes that all the extraction nodes would be able to share. Well, when you look at a system like that, and then you run the possibility that there are chunks that are not loaded, right? That list of insert nodes can become unstable, to say the least. And that is where a lot of this feature started to break down. Is the on paper, the system is sound and solid, right? If everything never got unloaded, if the chunks never unloaded themselves, and you had the pipe system always loaded in memory, always running, never a problem, whether the chunk was loaded or not, all of those block positions were all loaded all the time. The system was very, very secure. But once you start randomly unloading chunks in your base, depending on what direction, like how far away you are, this chunk could unload, or this chunk over here, or this one over there, or, like it's not set on the order that chunks unload in, and then it's not set the order that they load back in, right? You could leave your base from going south, and so all the north chunks unload, and it unloads in that direction, right? And this chunk unloads, and then all of these chunks unload. And then when you get back to your base, you might come back and approach from the west. Well, then all of the chunks are going to load back in, from west to east, and they're all going to load in this order. Well, all of those pipes that are in there are all trying to inform the network, like, hey, I'm back, right? And the network is trying to manage all this shit, and it's just like, I don't know, like this is crazy. Like, I don't know what's going on. So the system that I want to move to is more in line with the pipes mod after I did more analysis of it. And there is no concept of a pipe network. Basically, when a pipe loads, right, when you either place it, you place a neighbor block that can connect to it. That's important. If you place a neighbor, let's say you have a bunch of item pipes, right, and you place a tank next to it. Well, the item pipe is not going to connect to the tank, obviously. So if a connection is made, like an insert connection is made, that's important. So you can place 1,000 pipes that don't connect to anything, and the system should not care. It should just not care. The moment you place something that can be connected, well, that needs to then inform all of the extraction nodes to say, hey, there's a new insert node. Update yourself, right? And that is where those new algorithms that we ran, that we coded, were rebuild those insert nodes. Now, we could try to maybe add some helper functions to smooth that process a little bit, to make it a little less janky. Because if a neighbor block changes and the insert node is created, to be able to fast inject an insert node into all of the extraction nodes, just to tell all the extraction nodes, hey, there's a new insert node, right? And I just have it update itself, because we those are the things that are known. We know where the new insert node is, right? We know what it is. We just need to then inform all the extraction nodes that a single insert node was there. But if the block was placed that joins two networks or joins pipes together, you have a big pipe network on this side and a big pipe network on this side, and you place a block in the middle that joins the two up, now you have a different situation. You have a huge amount of stuff that you have to process on one side and a huge amount of stuff that you have to process on the other side. And now you have two different branches that you have to basically inform, hey, mark yourselves dirty. Just mark yourself dirty. Because there's a whole lot of shit that changes. And that's where the other helper function, or the other update, is grab all of the extraction nodes, grab all of the insert nodes, and then update everybody. Because everybody needs to get updated. Because now things have changed. Now there's two different networks that are connected. And so those kinds of calls, I'll probably be looking at how to make those better or at least not laggy. So the specific like pipe block placement where you're joining two together, two or more, that kind of call to update the whole system would probably do best on another thread, right? You just spin it off into another thread and be like, hey, update the whole system. And that would probably be the best way to do that. I want to be careful with that. Really careful. So we have a thing here that we have to do. Mark pipe dirty, I think, is too generic. We need we need to change this. Right? We need to basically when a neighbor block changes. So this is going to be we want to change this to basically like a new block. I think this is more, well, the code that's in here is more catered to when a new block is placed. Yeah, when a new block is placed, what do we have to do? So this mark pipe dirty is new pipe placed. And then we go to the pipe block, blah, 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 and we say on neighbor block? No. We say pipe BE dot new pipe placed. Dirty shape, true. Right? So dirty shape means, hey, like we need to build the connection information with the new block, right? We need to detect and update when it's a new pipe placed. And then the neighbor block is going to be a different call. Is going to be pipe neighbor, pipe neighbor change or something like that. And then we'll have a different one for the initialization, which is just going to be like base, like just initialize. And then block broken, same thing, is we need to make sure that when we break a block, if we're in the middle of blocks, right? If there's a pipe and there's pipes on more than one side of us, when we break that, we have to inform some stuff. Now, what I can do, what I'm hoping to be able to do is add a delay. The maybe 2-second, 3-second delay between the mark dirty event, right, and the actual processing of the update to give you lead time to where it's not constantly, like if you're breaking, like let's say you're breaking pipes, you've built a system and you don't like it, and so you're breaking one pipe after another. Well, when you're breaking those pipes, instead of firing mark dirty events constantly, you're firing constant mark dirty events that's constantly being picked up. What I want to do is I want to add a delay into that where the extraction nodes are not processing that dirty event like immediately. They're actually like saying, hey, let's delay this a little bit in order for more and more of those events to happen. And then once you've removed some pipes and 2 or 3 seconds go by, then it updates and says, okay, now we can update. I think that would be an efficient, like a little ways, a little bit of an efficiency, just to give a delay, because if you're constantly firing those events, you're going to bog everything down, especially when you have a really big pipe network. There's a lot of blocks to traverse. You're going to run into problems constantly firing those. Not that you should have enormously large pipe networks, but anyway, here we go. Let's see. So new pipe placed, dirty shape. Yep. Okay. Block pipe base new. Most of this stuff, get block entity, block facing, all faces of F. Where's F? I'm looking at all the faces. Okay. So I'm very happy that I put so many comments in here. This is why I put so many comments, because going back to code that you've already written is just very nice to be able to read it. Okay, so while the block is air, extraction sides. Yeah, see, this is what the problem was. I think that we need to look to see if the direction is loaded, is chunk loaded. Okay. So this check now calls is chunk loaded to check to see if the block that the face that we're looking at, because what it does is iterate through all 6 faces. When you place the block, it has to look at all 6 faces to see like what it needs to connect to. If a direction is not loaded, should we just see this, we're checking it here but not here. Right? If overridden sides, then connection was previously made to remove that flag. So yeah, this is where that bug comes from. We're basically saying if we've overridden the side, remove the override. Like what? Why? We shouldn't be doing that. This is where that bug comes from. I don't know what my logic was there. I think we need to check. Need to track network IDs? No, we don't. We're not doing network IDs. If not is loaded, continue. Just skip the direction. Right? We're grabbing whether or not the chunk that we're facing is loaded. Right? If that block is not loaded, I don't want to do anything in that direction. Right? Don't do anything in that direction. I mean, this should never be true, because now this call is only when you place the block, right? When you place the block, you should have all of the chunks around you loaded. So this should never fire. So I can actually remove the check here, and I can remove it here. And I can remove it here. Because it's literally like we're not yeah, we're doing a blanket check at the beginning. So what we want to do is we want to also do an int num inserts. Let's do num new insert equals 0. Extraction signs from that direct. Remember, this is a new block that you place. This should never be true. Never. It should literally never be true. Because when it initializes this, the extraction size of f would never initialize to true. A node only ever initializes to an insert node. Okay. We'll leave it in, even though this like if should never fire, right? It should never go in here. If overridden sides, I don't understand why I do this. Connection was previously manually overridden. What? No. If it's overridden, never ever ever reset it. It shouldn't be set anyway. Again, this is only on a new thing. If insert sides, what determines that? If ID equals 0, face direction is air block. Okay. What's my logic here? If insert sides of F, meaning if the insert side of the place that we were facing is 0, then it needs to remove right. We don't need this one either. Yeah, we don't need this one either. So let's just make sure. Position facing subnet and then distance. Yeah, let's. I'm going to leave this call in there. I need that error, right? I need that to exist. Num insert connections minus minus. I really don't think I need to use the bathroom again. Jesus. Come on, buttons. Do your thing. Okay. Man. It's to a point where I just can't think anymore. So yeah, like if this whole function is predicated on it's a new pipe placed. So if the block ID is 0, we don't even need to do anything. Yeah. So we're going to remove. We're going to say not equal to 0. And we're going to do that. So first we check if it's loaded, which it always should be. Like this is when you place a block, it should always be loaded. All of the chunks that are around you should be loaded. If the face direction, the block that's at that face is not equal to 0, right? So it's not an air block. Could be any number of blocks, but it's not an air block. Get block for air blocks and valve coordinates, blah, 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 blah. Read the block layers. Yeah. So if it's a solid block, it returns the solid block. If it's a fluid block, it'll return whatever is the fluid block. But it'll never return null. So if block ID is not null, so block is not air, meaning a valid block, could be fluid, need to check the entity. So if the block is the pipe, so if the block we're facing is a pipe use, yeah. So we're checking us. Yeah. So we're checking us. If it's a pipe, let's do another. We need to do int num neighbor pipes equals 0. Okay. So if it's a pipe and it's the same use type, right? Because we don't item pipes shouldn't connect to fluid pipes, et cetera, et cetera. Like we need to verify that the pipes are still that the pipe use is a thing. We grab the other block entity, right? We grab that the block entity of that pipe. We check its overridden side, right? The opposite face of what we're looking at, right? So let's say our face is north, F equals 0. That's north. Well, we need to check the other block's south face, not its north face. So we have to flip to make sure that we're looking at the same sides. If not, overridden side should always be false. So if opposite index, if this is true, overridden sides is true. Okay. So if their side is overriding us, which could happen, right? You could override a flag before you place another block. I don't know how that would work, but I definitely want to make sure that it does work. But if you override that flag, then I want to make sure to detect I want to set my flag as well. So then we look at this, if overridden sides, if not overridden sides. We set overridden sides equal to true. Connection sides, if not overridden sides, right? So if the side isn't overridden, which we set here, right? So if we set this to true, that means that other block controlled what we're doing. So that other block was overridden in our direction. So then we set our direction pointing at that to be overridden. Because that's what builds, right? That's what builds the little shape. It's a dynamic shape. So that other direction, we say, okay, we're not going to connect them. It's overridden. If it's overridden, so if it's not overridden, well, yeah. If not overridden, if not connection sides, right? So now we're instead of dealing with the overridden sides, now we're saying, okay, is this a valid connection side? If not overridden sides, which if this is false, it swaps to true, right? So we're not overriding it. And then this one is saying, okay, if our connection is false, which it would be on block placed. You're placing a new block. This is saying, okay, our connection is not set, right? Our connection. So now we set it to true, and we're marking the shape dirty, right? But this is not an insert node, right? This is another pipe. So we need to set num neighbor pipes plus plus. Right? We need to indicate we have a neighboring pipe that we're connecting to. Okay, so if connection size of F, which says that we just set this to true, and let's see, what does this do? Dot connection sides, so BEP. This is what we are connected to. Yeah, DBE is the face. So this is the block we're connected to. Dot connection sides. Dot opposite. Dot index. Okay, so this is checking the other block. Okay. This is looking at the other block, like the one that we're connected to. So our connection is valid. Hmm. Um, what? Okay, I think we don't need this check at all. I don't think we need this check at all. Yeah. Um, Because remember, that other block, the block, the when we're looking at the neighbor block, right? Our block is placed, and we're just kind of looking at it around. We're looking at it around ourselves, and we're saying, hey, who's around us? And we look at another pipe, and we're like, oh, we have a neighbor that's a pipe, right? Is it the same kind of pipe? Is it all of the various shenanigans, right? And if all of that matches, and we're like, hey, this pipe is not overridden, right? So the direction that it's facing us is not overridden, so it has a valid connection. We need to set our connection to true because we are able to connect to that. We don't need to do anything with the neighbor block because the neighbor block is getting the neighbor block changed event. And that event is going to look at us, right? That event is going to look at us. Now, I don't know the chain of events that happens and how early it calls it. Does it process our block placement event first and then do the neighbor block changes? I don't know, right? I'm hoping that it does. I'm hoping that our events happen on block place, update, blah, 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 block entities, all of this processing. And then once all of that happens, all of the neighbor blocks are informed, right? All 6 neighbors of the one we just placed all get that event. So num neighbor pipes is literally tracking the number of new neighbors that we have. That's going to be important because if that's greater than 1, there's some more shenanigans that we have to do. But we do a continue here because if our neighbor block is a pipe, then we don't need to do any other checks, right? We need to check else if can connect to. So this call is a base call to the transport feature of the mod. Can connect to is a very, very generic call. And it's very based on what kind of pipe that you have. But it is a base call for the pipe system. It's if you create your own pipe block entities, like if you create your own versions of pipes using all of these interfaces and stuff, the can connect to is a required thing. It's defined in the interface. It's defined in some interface. But the can connect to, this is the base call. It's like what, depending on the type of pipe, you just override can connect to, and you determine what your pipe can connect to. And that's how you create a new pipe. It's like, what can this pipe connect to? And then you have to define the transport handler, which is the interface. What is the transport handler for this pipe? And then that has certain functions that you have to override, or you have to have, which is what both of my handlers have. So it's just like, yeah, the system is built to be able to do that. So if we can connect to the face, right? Yeah, if we can connect to that face, because we're checking all of the different faces. We're going around to each square. If it's a pipe, we're tracking that. We're enabling our connection if it's not overridden. And then we're checking our connections. If it's a machine or a tank or something that we can connect to, we're checking if not overridden sites. We're making sure that we're not overriding. And again, we don't need those. Insertion, right? If we're not overriding, then we need to be inserting, because again, this is on block placement. And then we actually want to num new inserts, num new inserts ++. Okay. Num insertion connections, this is fine, but we want to make sure that the number of new inserts that we're tracking is valid. Num insertion connections, shape dirty equals true. Again, we only mark shape dirty if we have a valid connection of any kind, whether it's a connection to a pipe or whether it's an insert. Shape has to be dirty, right? And then the shape dirty, if shape dirty network ID was 0, blah 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 blah, get network. We don't need any of that. Mark dirty. I don't remember. If shape dirty, mark dirty, true. I think I catch this shape dirty event somewhere. I think it's in the tree attributes. Do I pass in? I don't think I pass in shape dirty. What do I pass in? From tree attributes. Mark pipe dirty again. Where this is the function that we just renamed. That's why it's not there. Okay. So shape dirty, I think that gets picked up somewhere. Yeah, there it is. On tessellation. So the tessellator runs in a different thread. So it's in the background, basically tessellating the shape. So we mark shape dirty, which is saying, hey, shape dirty is true. Mesh data may or may not be null. It all depends. This call rebuilds the shape. Okay. So, but only if shape dirty is true, or mesh data equals null. So we always have to have the mesh. So coming out of that, if mesh data does not equal null, which means we have mesh data, now we need to add mesh to the mesher that's passed in, right? So the way that the tessellator handles it is it calls, if this function exists or is overridden, when it does that to the chunk, it just draws, right? It's processing, it's creating the mesher, and it's adding all of the meshes in a chunk. It's just adding all of those together in one shape. And so my little function here is adding that mesh data to the mesher and saying, hey, we're adding some shape information, which is what this rebuild shape does. Basically, all this does is really detect what kinds of connections. It doesn't really do anything with the connections. It's just saying, hey, which connection am I? What is the shape reference code of the direction and all of that kind of stuff. So it's just like, what shapes do I need in these positions? So it doesn't really do anything with objects like networks or anything like that. We don't need to deal with that. But shape dirty, this is also set when our connection stuff is a thing. So if Keeping this one has a shape change, classing uniform, less frequent update. That's fine. If num neighbor pipes is greater than 1, if num new inserts is greater than 0. Okay. These are the two situations that we need to do. So again, we're getting away from having a network manage everything. Because in this kind of call, right, this is the place, this is where the code was that was going out to the network, grabbing and informing the network, hey, I've got a new thingy, right? I've got a new thing to check out. We're getting rid of that. The network does not exist. So the number of neighbor pipes greater than 1. Why is that important? Right? That's important because if the number of neighbor pipes is greater than 1, that means we're merging two networks together at the very least. Now, is that always the case? No. But if you're building a pipe this way and you're building a pipe this way and you place one in the middle, number of neighbor pipes would be 2. Right? So this pipe network and this pipe network now they're connected. So number of pipe connections is greater than 1. The number of new inserts, if that is 0, right? We don't really care. We don't really need to inform anybody. And so I think what we're going to do here is we're going to combine these. If number of neighbor pipes is greater than 1, or number of new inserts is greater than 0, then inside of here, we're going to do if, and then no, yeah. Number of neighbor pipes equal or greater than 1, or num new inserts greater than 0. So I'm just trying to figure I'm kind of sorting the logic in my head. Like all the different cases, right? All the different edge cases, you're gonna have to think about. All right, what are the cases? You place a pipe, right, and only has one pipe next to it, so number of neighbor pipes is 1. But you place it and it connects to a machine, so number of new inserts is equal to 1, so it's greater than 0. So that's true. In that case, I only need to inform one side. Like I only need to say, hey, there's a new insert in town, and we just need to inform all of those neighbors. We just need to inform, hey, this thing is new. But if we place a block that connects 2 pipes, right? So num neighbor pipes is 2. We don't know, right? This function does not know the size or extent of that of either side, right? It has no idea. There's no variable that tracks the number of insert nodes and the number of extract nodes in the network, because there is no such thing as a network. All it knows is that the number of pipes it connected to was greater than 1, right? That it basically combined 2 different networks. And each one of those, if you put one pipe on this side and one pipe on that side, and you place a pipe in the middle, the same thing is triggered. You're connecting 2 pipes. That's all it knows. So if num neighbor pipes, I don't know why it automatically selected the second one in that list, but num neighbor pipes greater than 2, Okay. Or greater than 1. So if the number of neighbor pipes is greater than 1, we have a much bigger update in store, right? We have to now massively update everything. So how do we want to do this? And then we want to do an else here. So, oh my God. I've been doing too much. I did a hashtag there for a comment because I've been working in EU5 and that's how comments work in those files. We are expanding, or we are connecting to different pipe systems, 2 or more different pipe systems. We are simply adding new insert nodes. So I know this is like, why did you do this in a nested if like this? I know this is, but in order to get my brain working, I have to do it in a way that like my brain logically can process this, because these two items are like semi-related but sort of mutually exclusive, right? If one is true, the other really doesn't matter, right? This is why I did this. Because this statement is like, if this or this is true, then come in here. But I need to know which one of these is true, right? Which is this if statement. Because if this is true, this is irrelevant. Okay? Really, it is. With the way that we're going to update. If this is true, it doesn't matter what this is. So then the first thing we check, is this true, right? If this is true, then this is true, obviously. So if this is true, this is irrelevant. But if this is false and this is true, right? Then we need to then it's a much softer update. It's a much softer update. So with this, we need to then run the full thing. Rebuild pipe graph world dirty shape. No. Rebuild pipe graph start position. Doesn't really matter what our start position is, but position. Okay. Why don't I have any help file? Where's my... Yeah. I need a... completely rebuilds all extraction node all extraction nodes on this system. All extraction nodes with a list of insert nodes. With a list of insert nodes it finds. Now, the start position, what... Okay, that's just where we start, right? This is the entry point, is where are we at? Where is the starting point for this, basically this graph search, right? We need a starting position. It doesn't have to be a node of any. It just has to be a start. right? And then from that, we could branch out in multiple directions. So imagine a case where you have 6 pipe systems all separate. You have 6 pipe systems all meeting in a single space. And then you place a pipe in that space that connects all 6 pipe networks, right? That's like the quote unquote worst case scenario. That's the most complex, is you have 6 different pipe networks or pipe systems. I'm going to call them systems. You have 6 different pipe systems all meeting independently in one block space, not touching, but like there's an empty block that has 6 faces that have pipes in it. And then you place a pipe in the middle that connects all 6 of those sides. Right? That is a huge amount of networks that you now connect. Now you have all of the extract nodes and all of the insert nodes on the whole system, all 6 of those. Now they're all connected. So all of those extraction nodes need to be updated. But we need that starting position. And that position could be anywhere. But what that does is it starts building the list from that point, and so it would branch out in 6 different directions. As it iterates out, you just have to imagine it's every iteration it's going another block space out, and it's basically adding up all of the positions. Now, if you have a lot of pipes that don't have a lot of insert or extraction nodes, it's doing that very fast because it doesn't have to mess with any lists. It's just growing pretty fast. So with this, we're just rebuilding the pipe graph, and that's all we have to do. Now, this is the call, possibly multi-thread this call somehow. So this call is it's a potentially costly call, right? Let's just say it's like in the worst case scenario that I've just described, where you have 6 different networks connecting to a single space, and let's say those connect, like every one of those 6 has a bunch of extraction and insertion nodes where you have just a ton of stuff. Well, it's gonna be a big ask. There's gonna be a lot of processing that's gonna have to be done. So placing that block could like noticeably cause a hitch in a giant system. Now, you really shouldn't be building enormously complex pipe systems. You shouldn't have incredibly complex pipe systems. You're just kind of asking for trouble. Now, we are connected to 2 more different pipe systems. Rebuild all nodes, node lists. Okay, so rebuild pipe graph goes in and rebuilds all of that. So this one now, this is a little bit simpler. What we can do, I think, is this is the situation where number of neighbor pipes is only 1, or it could be 0, right? Number of neighbor, it might be the first block you place, right? The first block you place might have a bunch of inserts, but no extraction nodes. So if number of neighbor pipes is 0, if number of neighbor pipes if you place a block, so you always think in edge cases, right? If you place a block with no neighbor blocks, which means there's, num neighbor pipes is 0. It really doesn't matter how many inserts there are at this point, because there are no extraction nodes, so it doesn't matter. So in that case, we don't even need to do anything. Number of new inserts, it could be many. But if number of neighbor pipes is 0, is this an edge case bug, or is this number of neighbor pipes equals 0? It's going to skip. Well, number of new inserts might be 1 or 2, so it'll still go in here. So number of new inserts. Again, this is just placing a new pipe. That's all this is. We're calling this new pipe has been placed. So in those conditions, right, this could be true. Number of new inserts greater than 0. But number of neighbor pipes can be 0. Right? So we're still in here. We're still in here if our number of neighbor pipes is 0. But our number of new inserts is greater than 0. So if num neighbor pipes equals 0, or let's just do greater than 0. New pipe has at least one pipe neighbor. Update any extraction nodes with new inserts. Okay. So if number of neighbor pipes equals 0, it does not matter, I don't think, because when you place a block, no node will default to extract. It will they will only default to insert, which you could have, if you, in a worst case, again, you could place a block. If you have a chest on 6 sides, you place a pipe in the middle, it's going to detect, like an item pipe, it's going to detect all faces are connectable. And so it's going to add an insert connection on all 6 faces. There will be no extract nodes at that moment. So it doesn't matter how many inserts that we have. There are no extract nodes. So we only need to update any possible extract nodes if we have another pipe, right? If number of neighbor pipes is greater than 0, then we have to do the check. So with this, we need to list pipe insert node new inserts equals new list. What I want to try to do, we have build an insert node list. Push connections. I'm trying to be optimal here. If we place a block that has, let's say you're building a system and you place a block that has one insert node connection. Okay. That's a finite amount of thing. We shouldn't need to traverse the whole, like we have a known insert node. All we need to do is inform any extract nodes of the change. Okay. So we need to then find and update any extraction nodes. And then this is where they where I would like to optimize. How do we cache kind of new to VS Money? Can I change something in the mod? In what mod? To let newer updates work on older worlds. I'm using 1.21.6. And you want the new stuff. Well, just wait. Like, it all depends on the mods. But in general, once your mods and stuff are updated, update the worlds. There's very little. No, when I compile against a version, especially the new version 1.22, there's a host of API changes. Okay, they're programmatic changes. They're not JSON. They're not simple text JSON changes. They're actual targeting the API calls that have changed. Those are not backwards compatible. You can't just install it on an old version with some JSON and get it to work. It's literally targeting a different version of the API, and if you're missing those calls, then it's just not going to work. So, and it's a huge amount of work trying to get it compatible, trying to get it backwards compatible. It's just I don't have enough time. I don't. There's not enough incentive for me to put in a huge amount of work to make the 1.21 version, all the changes I'm doing now, backport those to 1.21. There's just not. Once 1.22 comes out in stable, right, I'll be updating to that. So all these changes will be for that, depending on the time frame. They're already in release candidate for 1.22, but I'm still on 1.21 right now. But similar to an example, in the mod list, most mods, for the most part, there are obvious exceptions. But if you have a bunch of mods that are JSON mods, they don't have any code. There's no DLL in the mod. Most of those will be compatible right away. It happens, especially when they refactor a foundational system. But usually a lot of those, I made a mod. One of the first mods I made, it's called Rock Blocks. I made one called Rock Blocks and Quartz Blocks, and it just adds the ability to take the stone and convert them back into blocks. And I made that mod 4 years ago, and it's still compatible. I have never had to update that mod, right? It's just a JSON mod. It's a really simple, take the stone and convert it into rock. That's all it does. So depending on the complexity of the mods you have, they are more or less compatible. But yeah, code mods, especially post 1.21.6, right? A mod compiled for 1.21.5 may not work for 1.21.6. There was a fundamental API change that they did in 1.21.6 that broke so many mods. I mean, it was disastrous. And so they usually, Tyrone in the past has tried to only have API changes for the major versions, and then all of the minor versions, right? 1.22 has all of the big API changes. But 1.22.2, right, or .3, .4, those are just bug fixes. Typically, that's how he does it. And so once 1.22 stable comes out,
I'll download that and be compiling against it and make all the changes that I'm going to need to change to all my mods. There's a bunch of stuff that's going to have to be updated. It's going to be painful. But I'm sure it's going to massively break everything. But backporting that is really not possible. I mean, it's possible, but it's an immense amount of work for a very little payoff. Like, why? Right? You should be on the newest version of the game. This is not Minecraft. This is not Minecraft where people are still playing on 1.7.10 for Christ's sake. So you should always be playing on the newest version. And if mods don't update, right, that's just because mod authors don't make money, and there's no incentive to keep updating stuff that people download for free. So unless we as a civilization start understanding that mod authors version to version to version are not making any money, and there's really no incentive to keep going, I'm sorry, but some mods just kind of fall off the wayside. That's just kind of how it works. I've got, some support for the work that I do, so it kind of keeps me motivated and keeping going. But it's up to the person whether it's a passion project. As soon as a mod project goes from sort of a love passion project to something that feels like work, right? A new version comes out, people are like, hey, when's the update? Blah, 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 like spamming, like, when are you going to update this? As soon as it transitions into like, there's an expectation now, it loses its luster. So try to refrain when the new version drops. Try to refrain from going to all your mods and be like, when's the new version? Like that expectation is very annoying as a mod author. It's like, yeah, I'll get to it when I get to it. I'm sorry, but if you really want it to be faster, then throw me $10 or something like that, and that helps. But anyway. Okay, so where were we at? Override. Okay, right here. One new pipe has at least one pipe neighbor. So we need to this build insert node list. We need to iterate through the network. Let's call it the system, because network is too closely tied to a pipe network that I'm getting rid of. He was thinking about making his Rust overloads mode open source. I mean, most of QP text mod, like, yeah, I can see that. But making them open source, I mean, Vintage Engineering, you can go and download the source for Vintage Engineering, right? It's open source in that people can do updates and PRs, and we can work as a team. And if somebody wants to contribute, they can get the code and update it. And whether it's a JSON change, recipe change, or code, if you have something that you want to fix, like a bug or you want a feature, work on that and just submit a PR and say, hey, this is what this PR is. And I'll, if it's legit, and I'll review it. If it's something that adds awesomeness to the mod or fixes a bug or something like that, that's how an open source project works. There has been none of that really for Vintage Engineering. I mean, I've had this project going for 3 years now, and very, very, very few PRs to the code base. So yeah, you can open source something, but that means very little to the community if nobody is willing to help. And it's unfortunate that it's very difficult finding any help. Okay, so what we need is a function that basically public static void quick update pipe graph I world accessor world list pipe insert nodes nodes with nodes. Okay, so quick update pipe graph updates the extraction nodes on I need, since this is a static, from position. Update pipe extraction nodes from the given position with the list of given nodes. Called when a pipe is placed and it has and called when a pipe is placed and it has new insert nodes but not connecting multiple systems. World accessor. Find starting position of search nodes to nodes new nodes. Okay, so what we need is a list of all of the insert nodes. So for int f equals 0, f is less than 6, f plus plus, if insert nodes, wait, insert nodes, we should not let's see, where are we at? We have whoa. Okay. If insert nodes equals null, then insert nodes equals. So we want to make sure it's not null. And then we add any of the insert nodes. Right? We grab the side. If the insertion side is true, which we determine that up here, right? We determine whether if the block is a pipe, then we have a connection side. But if we can connect, then it's an insertion node. So we have to make sure the insertion node is the list is enabled, and then insertion sides we set to true because we're not overriding it. I should actually do that up here, right? Just because if all of the sides are overridden or something like that, then we want to make sure we're not initializing a system that we don't need. So num new inserts plus we create the node, pipe insert node position. We store not the position of the entity itself. We store the position of what it is connecting to, and then the face, right, that we are connecting to from face, which is coming from here. And then it's not going to have a subnet, and the distance is 0. We add that to the dictionary, num insert connections ++ shape dirty equals true. And then we come down here, and then if num insert nodes of f, well, why don't we do this? For each key value pair int pipe insert node pair in insert nodes, right? We have if num neighbor, so if num neighbors, we know that if we're in this else, num new inserts is greater than 0. So we want to, well, we already have the list of insert nodes. What are we doing? Why we don't need yeah, we don't need to create a new list with the list that we already have. So what we need to do is we need to call quick update pipe graph with the world position.copy. No, stop doing that. And then the insert nodes dot values. Dot to list. Right? So this is all the values. We don't need the keys. The keys is just like it's a quick index of whatever face it is. We're actually encoding the face into the node, right? So we already have that. Or we have a backup of it. And then this values dot to list creates a list from the values, basically a list of t, So it's passing in a list of all of the nodes into this function. So quick update pipe graph. Is there a way I can avoid doing all of this? Right. So essentially what we need to do is copy this, paste it here. And we're going to kind of reshuffle things a little bit. So this is going to be from position. Remember, this is a static. So this is not this. There's going to be no like instance data here. So whatever we use here, we have to pass in the data. So we give it a starting place. We give it this to poke, overridden sides. Insert sides. We care only about the extraction nodes. If overridden sides, continue. What does this do? Block facing. Okay, this grabs. This is what builds the graph, right? This is what sort of spiders out from our position. Now, when we place a block with an insert node, this will it should only go one direction. Right? It should go one direction because we're only connecting to one node. So it should only ever go in one direction or along the pipe in one line. And then obviously ignoring overridden sides. So extract nodes that contain. So extract nodes. So we want to do if B pipe extraction sides of F and position. Where is this position? Yeah, position. We need to check. We need to check whether the chunk is loaded. Accessing this kind of stuff, not ideal. Okay, get back up here. Now we jump to a position, right? And we do a 4 because there's 6 sides, so we have to look at all the faces. If we're overriding, just skip it. If we're not overriding, look at the direction. Is it another pipe? Now, there is a bug with this. So if extraction sides of F, right, we don't need to check whether it contains it. But if that side is an extraction side, then we need to grab and update that extraction node. Pipe. Let's see. BE pipe dot extraction sides, extraction nodes of F dot let's see. Little tufts of cat hair. I clean this stuff so much, and it's just everywhere. It's everywhere. We need a way of just quick updating an extraction node with the new data. Just in and out. We don't need a major tree rebuild. We don't need crazy amounts of stuff. We just need it to basically update. Apply upgrade. Yeah, okay, so public virtual void quick inject new nodes list pipe insert node new nodes. Push enumerator.dispose. If new nodes does not equal null and new nodes.count is greater than 0. Why are you doing the thing in the stuff? Why do you do that? Swear to God. It's like IntelliSense has been useful for many, many years. And their injection of AI into the system has royally foobarred the effectiveness of it. Because it just assumes everything, right? It always assumes that you're going to have some code, and 90% of the time it's wrong. Right? Rather than waiting for me to start typing, it's just like, blah, here's a bunch of code. It's like, how about you wait to see what I want to do before you just vomit up a bunch of stuff? It's like, it's not useful. When it just assumes what I want to do, it's not intelligent at all. Let me just put it that way. It's not intelligent at all. Right? It did that push enumerator thing because I did that at call up here. And it was like, oh, you're going to do this. And it's like, no, there's a way more that goes into this. How about you wait for me to actually type something before you go nutso with it? And so you want to do insert nodes.add range. And we want to do new nodes. But I don't know, adds the elements of the specified collection to the end of the list. Okay, we don't want to do this then. For each pipe insert node in new nodes. Okay, so because we need to basically inject when we create a copy of this, because we do need to make a copy. But when we do that, we can encode the distance value, which is, it's what we want. So we can either mark it dirty. Oh my God! Can I just close that? There we go. Initialize. We want to put that up too. I don't know why this stuff is so high in the list, but whatever. Mark node dirty, node list. So this wants all of the new nodes, right? This is rebuilding the entire list. It's sort of assuming mark node dirty. Let's put an add-on to this. Bool append list equals false. Okay. So this is saying tnodes.add unsorted nodes. So if append list else unsorted nodes equals t underscore nodes. God. Okay. So if append list unsorted nodes equals unsorted nodes dot add range of t nodes. Right? So if we're just appending onto the list, we're taking the unsorted nodes. Well, no, this is not what we want. This is not what we want. We want to do insert nodes dot add range, not node list. Come on, t underscore nodes. Okay. But then we need to sort it. Insert nodes. So we need to do push enumerator dot dispose. We can't affect this list until we dispose. We don't want that enumerator to be chilling. We definitely don't want that. So insert nodes dot add range, right? We're adding to the list of nodes already, but we're adding the list of, position modified. Language, this is C#. I love this language. Ever since I started using it back in 02. It was roughly introduced in like 02-ish. And I started dabbling in it. My God, it was like, this is awesome. This is so good. You are welcome. So insert nodes.add range. We're adding them to the nodes, and we need to sort. So if pipe distribution equals pipe dot farthest else insert nodes dot sort and then x dot distance. Well, let's do order. I think it's order dot order by. Okay. Do I have to insert nodes equals? Is this actually, let's see. Okay, that is not what I want to look at. What changes the distribution mode? Set distro mode. What sorts the list? What sorts my list? I mean, apply upgrade. Yeah. What am I missing? Ah. Because we add the new nodes with the new distances, right? And we just have to resort the list, which is why we got rid of the enumerator. So if append list is true, just append the list, right? Else, unsorted nodes and then we don't want to mark right, we don't want to mark it dirty if we've appended to the list, because this is a very specific call that gets picked up somewhere in here. Right here, right? So this cleans, when it's marked dirty, it's assuming there's some unsorted nodes. If there's not, right, it'll actually build the nodes. We don't want to do that. All we did was inject a few, like one or more insert nodes because there's a new block position. It's all we wanted to do. So we don't want to mark it, we don't want to set the isDirty flag when we're appending to the list. We just want to append it quietly, resort the list, and bug out. I may not want to do this, but let's go. Yeah, let's just clear that. I think in the handler, when we process the thing, get pull slot, when we do the get push slot, get push slot, nearest, farthest, round robin. Okay, so if push enumerator dot current equals null, node dot push enumerator equals null, or you can't check null status on an enumerator. Cannot be applied to operands. And null. Okay. It's probably why I didn't do it here. I probably tried to do it, and I was like, okay. So push enumerator. So it gets the enumerator. Push cons. Where is that from? Push connections. Push slot. Pipe insert node. Where it's getting these from somewhere. Insert nodes. So this function, the pipe extraction node, already has in it the insert nodes. I shouldn't have to send the insert nodes in here. Because the pipe extraction node now has all of its own insert. It has its own copy of all the insert nodes. So I'll keep that there for now. I should refactor that, but it is what it is. Let's look at this. Okay, so this is a thing that resets it when you move it beyond the list. It's saying, hey, this is false. Move next is false. So then it has to dispose of it and get a new enumerator. This is the way that it works. And obviously I had to put that in a try catch because I really don't want it to crash. Pipe insert node, yeah. So is chunk loaded? Yeah, there's the is chunk loaded. Yeah. So this checks pipe insert node current. So what is the current node? Is it loaded? Return null if it's not loaded. I should have a null check. Yeah, if push equals null. So if this returns null, which means it's most likely something isn't loaded, right? There's a chunk that's not loaded. So it's just point. It still does advance the enumerator, which is kind of funny, but it does advance it. It's null. The block is null, so don't do anything with it. I don't remove it, right? I don't want to remove it from the list. It just isn't loaded at that moment. So don't do anything, just skip it. Okay, so yeah, if we're appending to the list, just append to the list and leave. Don't need to do anything special. The next tick will update the enumerator. It'll detect that the enumerator was disposed because current will be null. So that'll it'll just get the next enumerator and start over. The expensive call though is this function just in general. It's just, again, this is going to be called every update. But again, there is a small efficiency. It's only called when there is an actual insert node. But yeah, bepipe.extract nodes of f dot quick inject new nodes. We want to inject the list that we bring in here with nodes. True. Takes 2 arguments. Oh. I just assumed since the IntelliSense had it that I needed it, but nope. Again, it was completely wrong about the actual function. It just hallucinated that there was more than one parameter. Like, why? It should know exactly how many parameters that call has. Why would it assume? It's like we've taken a step backwards with the IntelliSense when they moved the system over to use some sort of whatever AI is now driving this. It took a big step backwards because it's like it didn't actually reference the function. It just is like hallucinating what could go there. It's like the function itself doesn't have that. It should not be hallucinating. That's just really frustrating. Okay, so the extraction nodes, again, we're iterating through if bepipe.extraction sides. What we should actually do instead of this, I don't think we need to do this. Well, we kind of need to do this. Block position, get block entity. Yeah, I mean, this is fine. If extraction size of F, what I really should be doing, right, is bepipe.extraction nodes. I should just iterate through that list. It should be fairly straightforward. This kind of does the same thing, and this is already in a loop, so yeah, this should be fine. Poke.add position.copy, and then to add range, to add.clear, come back up. So this should process the whole thing. Quick update pipe graph. And then this call here injects the nodes into the extraction thing without right. This is processing the entire system, right? The entire pipe node graph processing it once and only once, and then just updating all the extraction nodes in the system once. Rather than setting all of the extraction nodes to dirty, the alternate to this, the reason why I'm doing it this way, the alternate to this is you process this, and when you detect an extraction side, you just set that extraction side to dirty, right? Extraction side, mark dirty, which comes in here, right? We mark node dirty, rebuild node list would have to be true, right? And you just set unsorted nodes, and then each then extraction node would then run the graph again, right? So rather than let's say the number of extraction nodes on any system is n. The way that I did it here with the quick inject, n equals 1, right? We run the node graph once. So we touch all of the extraction nodes once. So N1 is basically what it is. If I did it this way, where anytime, a simple update happened, it had to rebuild its node list itself, right? The extraction node itself was marked dirty, which required the rebuild. Well, then the problem is now it's n squared, right? Because the number of times that you have to traverse the list now is n times, right? It's the number of extraction nodes, every one of those has to hit it, right? So it's n times n number of times. So it's just very inefficient. So the quick inject is a way to... I thought I collapsed that. Is a way to run it here. So quick inject new nodes. Quick inject new nodes. Pipe extraction node. Didn't I? Why did you... I must have been concentrating on something else. Like literally this code is what I was going to put in the quick inject. So mark node dirty instead of the quick inject, right? Instead of this, which is literally what the code I just thought I was working on. We're going to do mark node dirty and then true. So we're passing it the nodes, which then it basically is going to create its own new copy of that with the distance factor from the extraction node. So mark node dirty. Let's just zip again to the definition. Append list. Node list. T nodes. So this takes the list that you pass it, creates a new list with the distance, right? All new nodes. Then if you're appending it, just adds it to the list and resorts. If you're not appending it, it throws it into unsorted nodes, marks it dirty, and then the thing will, the next time it ticks, it'll pick that up and do all the shenanigans with it. So that takes care of this. Yeah, we'll deal with that in a second. Mark pipe dirty. Yeah. Unblock placed. So that doesn't exist because we renamed it to new pipe placed. We need to do a new function, because I think this process is basically done. This thing processes all of the extraction nodes and updates them with just whatever we have. Rebuild pipe graph. We don't need to do that. Alter push connections. Yeah, I might just clear these out. I may just erase these. I don't think we need these. Okay, so what's this error? Mark pipe dirty from tree attributes. Okay, yeah. Let's see. We want to do int num extraction backup equals num extraction connections. Int num insert insertion backup equals num insertion connection. If num extraction backup does not equal num extraction connections, or num insertion backup does not equal num insertion connections. Shape dirty. So basically, this function is, again, called in two different situations. The first situation is when it's loaded from disk. When it loads from disk, all of these variables are basically initialized before initialize is even called, right? So it loads it from disk, runs this function, and then calls initialize, which can do a bunch more stuff, right? So when we run this num extraction, num insertion, these will be 0 in that instance when we load it from disk. These will be 0. Num extractions will be 0. Then we load it from disk, the num extract, num insert, right? We're loading those. And do we have num connection? Deserialize extraction sides. Connection sides. Anyway, so loading from disk, these, integers always, default to 0. So we shouldn't have any of these. There should be 0. Unless these try to validate. Yeah, they're just coming up with a number. And so they'll be 0, and then we'll load them from disk. So if either of these is greater than 0, right? These now variables, like let's say extraction is 1 and insertion is 2, right? These are backed up to 0. These are 1 and 2, which means they're not equal, which means we need to rebuild the shape. The other situation I need to look at is the connection sides. If we have connection sides. I wish there was a really easy way to determine if any of these changed. So the second scenario that this is called, other than stuff loading from disk, the second scenario is a server updating a client. A server sends a packet to a client with all the relevant tree attributes, and a client picks up the packet and is like runs this function on the tree. It's not reinitializing. It's basically like updating the client with all the new values, right? This is when you're looking at a machine and you're seeing power fluctuate, you're seeing progress of crafting fluctuate. That's the server spinning out updates to this client, right? The server is updating the client, and I rate limit that to twice a second, right? Every half a second, the server is spinning updates to the client for machines that are operational. Or a machine that's actually running, it's spinning those updates out. And so you're seeing as a client, when you're looking at a machine, a more spaced out update loop than the server is actually running. Because my machines tick at 10 times per second, right? But the client is only updated every half a second. So this is why those values jump more than like a nice graceful curve. In order to get, progress bars that are really smooth, right? In order to do that, you have to spam update the client, right? And that just saturates network bandwidth. You don't want to do that. You want to be very, very careful with how often you update clients with new information, because it's running this function up, like redoing all of these variables, and then it's up to the code to basically update any of the variables that you need in the UI and like when you have a window open and you're seeing all of the things, that all of that is coming from the server at a certain rate. And so you can control how often that happens. But when this loads on a client is going to have some value here. Let's say you, in the situation where the pipe exists, right? And then a neighbor block changes. Well, then that neighbor block change, if that connection is enabled, well, the number of insertion connections won't match. We'll go from 0 to 1. So this will grab the insertion backup of 0. It'll take from the server, we have 1, which down here it'll be like, oh, these are not the same. Our shape is now, our shape has to be dirty, right? Which should redraw the shape for the next big update. It should, and there might be, I don't know, there might be a little delay. I'm not 100% sure on that. It's going to take some testing, but we just want to make sure that we control when the shape is redrawn. Rebuild shape. let's see what this definition is. Mesh data, connection sides. So we need to possibly track or at least make convenient a num connection sides. I don't think there's not going to be a graceful way of doing that. So public int num connections num pipe connections get for int f equals 0, f is less than 6, f plus int num num equals 0 if connection sides of f num plus plus return num. We're just iterating through, right, all of the sides, and if we have a connection side, whatever face that is, right, the faces are 0 to 5, northeast, southwest, up, down. It just iterates through all those booleans, which should be very, very fast. And if that side is true, right, this is a Boolean array. If that side is true, that means there's a connection on that side, which we need to increase because now we have, hey, that's a pipe connection. So we return the number here. And so down in the from tree attributes, oh Lord, it's way down here, isn't it? Right. So we say we back this value up, int num pipe cons equals num pipe connections. Right? That grabs that integer. And then down here, again, we want to say, let's do this, or num pipe cons does not equal num pipe connection. I should probably rename this backup. So numpipe cons backup does not equal numpipe connections. So this can be true, or this can be true, or this could be true, or they all could be true, or any combination thereof. If any of those are true, rebuild the shape. Right? We're on the client. The client needs to rebuild the shape. The server does not care, right? The server does not care at all. The server doesn't have a shape. It doesn't care. Only rebuild the shape on the client. Now, should I call rebuild shape or should I just mark the shape dirty? I'm not. I mean, we're just forcefully rebuilding the shape. I think that should be fine. Mesh data is not equal null. Add mesh data. Load level. Yeah, I think I just want to mark it dirty because this. This is the thing that, yeah. Yeah, let's just set it to shape dirty equals true. Just to be on the safe side. Okay. So yeah, we're saving a backup of the NumPipe connections. Now these variables, we have to be careful. These integers we're managing, although I really shouldn't. Those really shouldn't be like that. The booleans here are not yet initialized. Right? We don't initialize these to a value, so it's kind of possible if connection sides equals null, return 0. We want to make sure we're not trying to index into a null array. That would be bad. There's probably an more elegant way of doing this, but a lot of the newer, like, inline elegant ways of doing things, some of them I don't like. Some of them are awesome, but some of them are like, I don't really like doing that. Like, this is fine. I understand what this line does. Now, this is, more of a new feature, but, understanding what this line does is very helpful. But like, yeah, mark the pipe dirty. See, this is the thing. Initializing this, for now, I'm going to remove the line. Unless or until something is bad. Num extraction connections is greater than 0. Graph dirty. If true, extraction nodes in this position will rebuild their. I don't know what I was thinking with this. I was thinking about something. I'm trying to think. There's a scenario where I rapidly hit on and rebuild nodes, but I'm trying to avoid too many shenanigans. So this, it's not going to hurt anything sitting here. If extraction nodes is not equal null, oh yeah, then we initialize. No, this would crash if I tried to do this. This is wrong. For each key value pair int extraction nodes. Face code. Pair.value.face. I don't know why I have to pass the face code into the thing that's already storing the face code, but whatever. Like the value, like pair.value is the pipe extraction node. It has the face code in it. I don't know why I'm then passing the face code into this function unless I had some shenanigans with inventory.late initialize. That face index. Okay. Okay. Yeah, the way that I implemented the extraction nodes is kind of a subtly hacky way of doing it, trying to work with the game systems. Each extraction node is itself a block entity. It's a little self-contained block entity. That's how I do it. It's not, because the game has a bunch of built-in shit already, so it's a block entity container. So it's just a custom block entity. Defined as a block entity container, and once I have that, then I can use all of the built-in functions of the game to manage it, because it's like it just assumes like, hey, it's a block entity container. I need to have all the things. So it has an inventory, it has a GUI, it has all of that stuff, all contained right in a little package, but there can be like 5 of these in a single block space. So a block entity of a pipe can have 5 little block entities inside of it, which is what these are, right? They're just little block entities. So kind of a cheeky way around that. And then the block entity of the pipe is the thing that manages all of these. It manages all of the data and all of that kind of stuff, as well as if you break or change an extraction node with that face, it drops the inventory if it has a filter or stuff in it, or upgrade. It cleans that up, as well as getting rid of the tick listener, and it kind of has to manage that a little bit. But the inventory has the position, but again, there can be several inventories with this data. Inventory with XYZ. Remember, you can have like 5 of these. 5 or 6. I mean, if you had 6, it's stupid, because 6 extraction nodes wouldn't go anywhere. Nothing would be moved. So let's say 5 is your max. Well, that's 5 extraction nodes with the exact same inventory ID. Well, that's not good. So I have to then encode the face index right into that inventory to know when you right click a node, an extraction node, I need to know what face index that is. And that's one of the things that's encoded with the block selection event, is what face index. So it's like, again, it's kind of a cheeky way of doing it, but I was quite proud that I actually got it to work. Okay, so yeah, we have, I think, all of that. So when you place a new pipe, all we've done today is when you place a new pipe on block placed, right? Called when the block has been placed through whatever method, right? Except during world gen or exchange blocks, so it doesn't get called from then. But we don't care about those two. You shouldn't be placing these blocks when you world gen anyway. Or if you do, it won't update. It'll be minimal processing. But we call the new pipe block placed, which is what we worked on today. Similarly, on neighbor block change is going to be a slightly different but unique a unique thing that has to be processed. So new pipe placed. So we do public, virtual, and I do virtual just in case somebody wants to override, these in a add-on mod. Pipe neighbor changed. iWorld accessor world block position position changed. Okay, do we have any other data? We have the block position of me. Yeah. So let's do block position us block position neighbor. Okay. I try to name my variables, somewhat understandably. So a neighbor changed, right? A pipe neighbor changed. So we get the call when a pipe neighbor changes. So this is now going to be pipe neighbor changed. And we're going to pass in the world. We're going to pass in us. And we're going to pass in neighbor. Right? We're just going to pass those in. And it's like, oh, here we go. We're going to drop those right in. So now we need to say, okay, what is relevant when a neighbor of a pipe changes? Okay. Well, one thing is relevant. Can connect to, right? This is saying world. Block position is going to be neighbor. Block facing. Well, I don't know if that's necessary. Which face are we looking to connect to? Which would be, how do we calculate that? I need to use the bathroom again. I'll be right back. All right. What is the So I have it on good authority that it's somebody's birthday today. And I just wanted to wish Parker a very happy birthday. If you're out there. Anyway. Going into the terrible twos. But anyway, yes, happy birthday. Good times. Now we have I remember almost learning it for the XDA. XDA, or was it XNA? Because they were trying to pull from DNA, so I thought it was XNA. But yeah, that was way back. Xbox 360. Yeah, that was way back when they had like they had some API that was made it easy to make games. I know there was a bunch of games that used it. Then when they dropped it, it was just like, okay, I guess it's not going to be useful. So how do we detect block facing face equals block facing dot from normal how do we determine what face from us to our neighbor, right? Us dot to face returns the direction moved from the other block's position to get to this block's position. Okay, so returns the direction moved from the other block position to get to this block position. So what we need then, I think, if we want the face that we're connecting to, which is what this function needs, can connect to, returns the direction moved from the other block position. So I think we need us and then neighbor. Right? To get to us from the neighbor, what face moved from the other block position, which is what we passed in. So returns the direction moved from the neighbor to get to this block position. I want to say that's right. Obviously, it could be the opposite of that. So, face. If can connect to. Okay, so this is one of the things is can we connect? Called when a neighbor block changes when this pipe has a neighbor block change. Okay. So if we can connect to it, do stuff. Okay. Now we want some of the same kind of thing here. So if we can't connect to it, so can connect to, I think only checks whether there's an actual like insert connection. Right? Yeah, this doesn't do anything because it's overridden by the actual individual pipes. So if we actually look at like the item pipe, can connect to is the primary call because it's, and this is all of the I had to do a bunch of exclusions here because they're all technically inventories. There probably is more that I have to do here, but the game doesn't differentiate between a stupid little itty bitty inventory like a cheese wheel and a chest. It's the same. It's an inventory, right? So it's just, it is what it is. But I check a dummy block, right? That is the integration with my multi-block system. Then I check the base game multi-block system. Then I grab the block entity container, right? Because that's really what I want to know. I want to see the block entity container, which is what I want to check. So if the block entity container, and then I look into it and say, hey, is it inventory? So this only checks, right? Only checks like insert node or extract node connections. That's all it checks for. I got lost. Why did this? New pipe placed. Oh my god. Pipe neighbor changed. There we go. I don't know why my brain just sort of fritzed out. I don't know why I was lost track of it. So only checks someone placed placed something that has insert extract potential. Okay. So we do an else. So if the neighbor block changed and we can connect to it, right? That means an insert node needs to be enabled. Right? And the face again is returns the direction moved from this to get to this. Right. Which is a weird way of doing it. That's a weird way. Returns the direction. So from the neighbor's perspective, how to get to us. You would think that if the neighbor changed, that we would get what direction do we have to go to the neighbor? Like what direction is the neighbor? But we could do that with just neighbor dot facing from us. Like you just swap those variables. But we don't really have to do that. Once we do it once, we don't need to do it. We don't need the other phase. We just swap the phase. So with that phase, then we basically want to pipe insert node new insert equals new pipe insert node. And then we want the neighbor, the face, block facing towards the block. So we go face dot opposite string dot empty, distance of 0. Okay, so this is the new insert node. We want to do insert nodes dot add new insert. String key is face dot opposite dot index. Right? So pipe neighbor changed. The insert node, right, is what we're connecting to. We're adding it to our list of insert nodes. Man, I really should. I need to generalize the algorithm. Yeah, somehow. Because again, we have a new insert node. We need to trigger. Again, we need to traverse the list and do all the things. So this is why I was like, I need to generalize this so I don't have to rewrite this algorithm over and over and over again. Quick update pipe graph. Update extraction nodes from the given position with the list of given. Okay, so this might be what we need. Yeah, this is what we need. Quick update pipe graph. We need to update the extraction nodes with this new insert node. So then we need list pipe insert node new node list new pipe insert node quick update pipe graph world from position is us, right? With nodes, new node list. Why is this all grayed? I hate when this is like, yeah, simplified. Yeah, this is another shorthand thing that you can do now is just new node list equals, and then a bracket is just like, hey, this is what I'm adding. Quick update node graph, and then we just pass in from our position. We pass in like the new list, because this should then branch out should take the list and basically, inject the nodes into that. Even though it's just one node, it still has to be a list, right? So, am I way off here? Yeah. God dang it. There it is. So that is handling whether we can connect to it or not. If we don't connect to it, a neighbor block changed, we can't connect to it. We need to then check if that neighbor is another pipe. Okay, so block NEIGHBR block equals world.blockAccessor.getBlock of neighbor. Okay, so what is the neighbor block? If neighbor block is block pipe base new BPN, right? If the neighbor block is block pipe base new, well, I don't really think I need the block. What I should just check is because I need the block entity. I need to look at the block entity. So if the block is is one of the new pipes, pipe use is what I need to check. Is that a block? Block pipe base new. Yes. So if base.block.pipe use, well, how did I do that here? Us. Yeah, okay. If neighbor block dot pipe. Oh, that's where I need it. Block pipe base new. If block pipe base new dot pipe use equals us as block us no base dot block as block pipe base new dot pipe use. So if the block we're pointing at, right, if our neighbor block is a pipe and the uses are the same, right? If one is fluid and the other is item, this would not be true. So ignore it. But if they are true, if their connections are, or if one can connect to the other, right? And when we place a pipe, we detect neighboring pipes, whether we can connect to them. What we don't do, right, is let's see. I just want to see this here. New pipe placed. what we don't do is mess with that pipe's connections at all. I used to, but I realized that was folly. I don't want to do that. But we do detect the block. We do look at that and say, is this side overridden? Right? So we look at the opposite face and we say, all right, is this overriding the side? If it is, then we override our side facing that. Otherwise, we don't do anything. So then the block, this call is now the block. When you place pipe A next to pipe B, the first thing we did earlier in the stream was work on pipe A. When you play the block you placed. Now we're working on pipe B, the neighbor block, the block that you checked. So the neighbor block gets called and is like, okay, a neighbor block changed. And so if our neighbor block is a pipe, and if those uses are the same, right? And so now we need to check the neighbor's overridden side again to make sure that we're not connecting wrongly. And what we need to do here is block BE pipe base new pipe neighbor BE equals world dot block accessor dot get block entity of type BE pipe base new at neighbor position. Okay. So get block doesn't ever return null. Okay. Get block entity, I believe, can. Yeah, returns null. So we got to be careful with this. If neighbor BE is not equal null, which is what we want. If it's not null, which means it should be valid, now we need to if neighbor BE dot overridden sides of face dot index right. Neighbor BE dot overridden sides face dot index is the face that should be what block, what is the face of that block to get to us? Right. Returns the direction moved from them to us. So we're now checking that side. Is that side overridden? It really shouldn't be, but just in case that it is, we need to honor that. And we need to ourselves overridden sides of face dot opposite dot index equals true. Else connection sides of face dot opposite dot index equals true. Right? So if their face to us is overridden, then override us to them. If that's not the case, then connect to them. Right? I probably need to check neighbor BE does not equal null and overridden sides of face dot opposite dot index, and I need to say not. Right? If our face is overridden to them already, right? Remember, we're the neighbor block. We exist. We were not just placed. So we have the ability, somebody could place the block and override the side in some way, right? I'm not sure how, but you could override the side and then place the next block. So our side is already overridden. The next block placed, we'll see that, and we shouldn't override then. So we need to make sure that our overridden side to that face is false, which is this not, right? Because if it's true, if the side is true, then this not switches it to false, which causes it to be skipped, right? Because we have an and, so it skips. And then we have connection sides. Either way we do this, we shape dirty equals true, I think. Right? Either one of these scenarios. If the other side is overridden, we may not need it in this case. We would need it here though. So, because if it's overridden, we shouldn't have a node facing them anyway, because there was nothing there, unless you had a swap. I don't really know if you had a swap. The other thing is, this would also, so now we're doing like one case after another, right? First case is, can we connect to the neighbor that was just changed? That means somebody placed a chest or a tank or something like that we can connect to. So that in that case, we create a new insert node, because there's a new insert node in that direction, encode it all, and then blast that quick update to the pipe graph, right? Somebody placed a chest. There's a node that inserted. We need to then inform all of the extraction nodes of that change. Okay. Now, so if that's not possible, which means the neighbor block was not something that we can connect to. So now we're back in here. Now, if that neighbor block is a pipe, else neighbor block is pipe, is a pipe, then, right, then do some checks. And then if we do else, if it's not a pipe, if neighbor block dot id equals 0. Okay, so if neighbor block is not a pipe, but it is air, id equals 0. Remember, get block will never return null, right? So it returns air with an id of 0 if there's nothing there, which means someone broke a block that we may or may not have been connected to. Okay. So someone broke a block. Now it is air. So now the problem is, okay, how do we remove an insert node from all the extraction nodes? Or what if the broken block, well, we already have the face. So the neighbor block int face 2 equals face dot opposite dot index. Face index that was toward the neighbor. Okay. Because this facing from, this is the face, like what is the face that the neighbor has to us. But I want what is the face that we have to. If connection sides of face 2, else if extraction sides of face 2. What the hell just happened? Else if insertion sides of face 2. Okay. I don't usually like long if else if change. I usually don't, but in this case, we have to check each of these possibilities. Because if the connection sides changes, right? So the neighbor block ID is now 0. So we know our perspective as the neighbor block that got this update. Our perspective is our neighbor just got removed. It's 0. So we need to check our sides. Again, this can be called if you have dirt underneath the thing and you break the dirt block, right? The neighbor block is looking down, right? It's saying that that is now air, but we didn't have a connection, we didn't have an extraction, and we didn't have an insertion side in that direction. It's dirt. Nothing is connecting to it, right? So in those cases, we don't need to do anything. But we need to make sure that we didn't have a pre-existing connection in that direction, which is what I'm looking at here. Right? So we're looking at the face that we're looking at towards that block was it a connection, which meant we had a pipe connection in this direction. We had an extraction node in this direction. We had an insertion node in this direction. Okay. So pipe connection, extraction node, insertion node. So we need to clear and drop node contents. Clear extraction node references to this insertion node. So if we had a pipe connection, do we want, where do we want? We have one more function here, on block broken, right? On block broken is the nastiest one because you could be breaking any number of things, right? Any number of block conditions. It's not just neighbor blocks, but again, if you break a block that has 6 other, let's say you have a pipe that has pipes on all 6 sides that go separately. They're separate systems. They're not routed around and looped around. It's just you have 6 separate systems all connected to one block, right? These are the edge cases. These are the scenarios when I'm programming. I'm thinking of the extremes on either end, right? That is that situation where you have a single block that's connecting all 6 of these separate systems, and that block is broken. Okay. Well, you break that block, which is fine. But what is the mechanism where all of those separate, now that those 6 networks, those 6 systems, all of those are going to get a neighbor block changed event as well. So we want to make sure that we're not doubling up expensive function calls like retraversing lists. We want to make sure we're not doing that, right? The only other thing that's hard to know is, are we still connected, right? In the case scenario where you have 6 pipe connections in one block space and you break it, the 6 neighboring blocks all get this call on neighbor block change, right? Pipe neighbor change, right? So in one extreme of this scenario, none of those 6 systems are connected to one another. There are 6 wildly different directions. They all go branching off and do different things, and none of them are connected. So in that situation, we want to call the retraversal, right, on all of those nodes, right? All of those neighbor blocks need to rebuild their insert nodes, right, because they're separated. So that's the best case in this situation, is you have all 6 networks, all 6 systems are separate. They rebuild their lists, and you move on with your day. The worst case scenario, again, I have to, when I'm coding, I'm looking at the best case scenario and the worst case scenario, right, in those situations. The worst case scenario is all 6 networks, all 6 directions are all connected in other places, right? Far beyond the block that you just broke. All of those networks are connected themselves. Okay? So that's the worst case, because if we are, as a neighbor block, getting those events, we are triggering the Mark Dirty event, which should try to rebuild those networks, right? It's going to retraverse starting at the neighbor block, right? The block that we're looking at. It's going to retraverse the list and update all the extraction nodes with all the insertion nodes, right? It's going to run through the whole network and figure out all the insertion nodes and all of the extraction nodes, and then update all of the extraction nodes with a list of all of the insertion nodes, and that process is going to make copies of it. It's a huge function call. Like, it is a very expensive call, and you want to do it as little as possible. The problem with the worst case scenario with a broken block event, the problem is when these networks are all connected to one another and you're calling 6 rebuild node graph events, you're calling it 6 times. All 6 times is retraversing the list, and it's refinding the exact same list of extraction nodes and insertion nodes, right? And it's re-updating all of that memory 6 times. That's the worst case scenario. So I have to figure out a way, and if I'm open to suggestions, of minimizing that shit, right? I have to minimize that, because as a neighbor block, I don't know who's connected to who, right? All I know is myself and the neighbor. I don't know any other information. Now, I could go crazy and based on the neighbor position, grab all of its neighbors and look at all of its neighbors, right? And try to hold hands with all of its neighbors and say, hey, let's update together. But then that can get into some shenanigans with chunk loading and God only knows what. So if I go from the perspective of neighbor block changed, if in the situation a block or the pipe is broken and severed connections. So I think I'm kind of convincing myself of the answer as I'm talking. This is how you can ask anybody who sits in chat with me while I'm doing this stuff. I still have to talk through it. It's so much easier for me to talk through the logic. The neighbor block changed event, if all we cared about is if we can connect to the change, so if we can connect to it, then we need to update our stuff. And if that neighbor block is a new pipe, right? If we're placing a pipe and that neighbor block that we get is a pipe and we can connect to it, go ahead and connect to it, which is what this does. But if it's ID 0, which means the neighbor block is now air, in that situation, I think what we need to do is just minimally handle the connection sides and drop contents. But as far as if that was an insert side, so connection sides here, I think this will be a minimal, like, we're just going to do connection sides of phase 2 equals false. Okay. Shape dirty equals true. We need to clear and drop node contents here. Now, extraction nodes, clear and drop extraction nodes. So we want to do pipe extraction node enode equals extraction nodes of phase 2 enode dot on node removed. Okay, because we're breaking that block, right? Our neighbor block, we used to have an extraction side in that direction. Now we don't. There's nothing there. We broke that block. Now that extraction node is invalidated because we cannot have it continue. So we have to call the node because it's trying to tick. It's ticking this whole time to extract stuff. And the moment you break it, we don't want to do that anymore. We want to stop that. So on node removed basically drops the upgrade, drops the filter. If those are set, it cleans that up, removes the tick listener. All of that stuff is handled on node removed, right? If we go to definition. Push enumerator to dispose, drop contents, slot modified, and we should remove the listener. Why are we not removing the listener here? Okay. I have to do it in the block entity because that's where the listener IDs are. So extraction listener from the face index. Okay. So remove extraction listener from face 2. Extraction nodes dot remove face 2. I need to see, no, not there. This is pipe-based new 250. So go to here. Ooh, that's way up here. Okay. I think here we want to do, this is a dictionary, so we want to extraction nodes dot remove face index. Extraction sides equals false. We don't need to do this. We just did it. Okay. We call the on node removed. We remove the listener. We should do this like right away. Like we remove its inventory. This drops its inventory. We remove the node. We clear the side, and we decrement num extraction. Okay. I'm gonna have so many bugs to clear. I can already, like, there's gonna be so many little, once I get this thing compiled and able to be run, there are gonna be so many things to fix. So yeah, I want to do this first. Okay. I don't need this. I need to extract nodes of face index face 2 dot on node removed. Okay. Extraction nodes dot remove num extraction connections minus minus. Okay. Remove the listener. Call the on node removed. Remove the node. Decrement num extraction connections. Okay. Shape dirty equals true. So again, we don't need this. Now, insertion sides. Again, I want to take, let's see. I want to do a minimal amount with the neighbor blockchain. So if the insertion side is different, I need to remove. So insert sides. Insert nodes. dot remove phase 2. Okay. Okay, and then insert sides of phase 2 equals false. Shape dirty equals true. So if it's an insert node, we break the block. Insert nodes dot remove. We remove that insert node. Insert sides of that direction is false. Shape dirty equals true. But in this case, we need to inform all of our extraction nodes that the insert node, this insert node is removed. Right? So we have a quick add node. New pipe place, that's good. Quick update pipe graph. Updates the extraction nodes given position with a list of given pipe insert nodes. So what we could do is and again, this is just a single edge case where you break a block that has one little insert node, and you just need to update the extraction nodes. So, what we need is this. Remove we want to do remove insert node. Okay. Remove single insert node. Block accessor world, pipe insert node to remove. Okay. So this is the insert node that we want to remove. Remove a single insert node from that given pipe from a system pipe system I don't know how to word this. I'm close to getting done. It's about 5 hours. Remove a single insert node from a pipe system starting at from position. Starting at from position. World accessor. Position to start search. insert node to remove. So the insert node, right? Remember, each of the extract nodes will have a slightly different version of the insert nodes because their version of the insert node is going to have the distance encoded in it. So what we're going to need is we're going to need to pay attention not to the actual object of the node. We are going to need to like surgically remove any insertion node that matches the block position of the removed area, and say just the block position is important, right? Because we need to remove any nodes in an extraction node that are referencing that block position, right? So this remove single insert node, again, it's going to have to run the graph and be like, I need all of the like extraction nodes in the system. I really wish I would have figured out a that'll be future Buggy's problem. Right. So this algorithm here is what I'm talking about. Like this algorithm is, I wish I would have built this in a way that said, hey, we can abstract this into some generics or something like that. Like, but that kind of comes later. Remove single insert nodes. So what I need to do is I'm just going to copy this. Okay. So we're starting from position and we're iterating through this list. Okay. So now, this check is not what we want. Well, yeah, extraction nodes of that. So we do need to look at extraction nodes, but now we need to go to the extraction node, right? And I'm sure there's probably a function here that I never finished that was remove node or something like that. It would make sense. On node removed. No, that's not what I want. Nope, that's not it. Huh, I guess I didn't. Okay. So we need to then go public virtual void remove insert node, and then pipe insert node. And then, well, we want to do push enumerator dot dispose. We want to do insert nodes dot remove range. No, we want to remove all. Predicate match. Remove all where x dot block position equals node dot position. What does this return? Right, returns an int. Int num removed equals. Let's just make this an int. And return num removed. Very, very simple. Insert nodes dot remove all. So we are just like, we're just saying, hey, we're going to pass in an insert node, which is going to have a block position, right? Which is what position, which is the neighbor, what position is now cleared? Which could be a chest, a tank, something, depending on what's connected to. Now remember, there could be more than one pipe, right? There could be more than one insert node. If you take a chest, let's say you have a chest that has an extract node, and you have a couple pipes, and then you have another chest, and then you wrap the other chest around with insert nodes, right? You have insert nodes like on 3 different sides of the other chest. Well, those are 3 separate insert nodes, right? So the extraction node will have basically 3 copies of the insert node with the same block position, but varying distances, because each one of those connections is a different block position, which means there's going to be a slightly different distance associated with that. So you'll have 3 different inserts, but they're all going to be slightly different inserts of their distance, but it's still the same block position of the target. And that's what we're removing, is the target. And so all 3 of those insert nodes need to be removed because they point at the same target, which is what we're doing here. We're removing all from this node that match positions. We don't care about distances. We care about the positions. And we're just excising those insert nodes, right? The list really doesn't need to be resorted. It doesn't need, we're just kind of popping those values out of the list, and hopefully, I hope that the .NET doesn't scramble the eggs of how this works. But if we have to resort it, we have to resort it. But it is what it is. But we want to clear the enumerator, right? We don't want to mess with this list with this enumerator active. That's a bad day. You don't want to do that. So this insert node, we're removing that node. So going back into our object again, we're going to say this, right? We're passing in the node that we want to remove, right? So we're passing this in. So we want to remove insert node, and we want to pass in to remove. So again, we're iterating the tree. And it's, simple networks should be really easy. And I could even, I could make it even faster. There would be a way when I iterate this list to only look at the direction BE pipe, get block entity, to poke, to add. Over insides, else, on directory. So this is actually looking for pipe blocks. What I should actually do, what would make more sense, maybe it could be an efficiency, is just iterate through all of the connection sides, right? I shouldn't need to get the block and look at the block and then look at the contain, is this contained? I should just iterate through, what are my connection directions? Because I shouldn't care about insert nodes. I should only care about where the pipes, what directions are we iterating through, right? Are we iterating in that phase? So it doesn't matter what the pipe is, right? The con direction, which is basically moving ahead into that phase. So rather than be a volumetric search, it's limiting it to northeast, southwest, up, down. But I should be able to even limit it even more. So con direction. This call here is in terms of an algorithmic standpoint, it's more expensive than just looking at a Boolean array. So why don't we prototype that and do connection where am I? Oh, I'm in a static. That's why. Well, I could do BE pipe dot connection sides of F. That. So BE pipe is the block entity of the pipe of whatever position that we're at. And then we're iterating through all 6 faces. And if the connection side of that direction is true, which means we have a connection, right? We have to check to see if that direction exists already, right? Have we already added that position? If not to add contains this. And I think we need to do poked. Okay, we already checked whether we've poked it already, right? So we've already looked in that direction and said, hey, have we looked at that already? If we have, don't look at it again. If we haven't, right, then add it. Right? We want to add it because we haven't looked at it yet. But only if we haven't added it, right? So this when you have a bundle of pipes, this is trying not to touch them more than once. But this is a little bit better of a call than this. Because we're not having to index into the block accessor. Like this is a huge amount of memory, right? I'm just like, what amount of memory do we have to cache onto the CPU in order to have that call return a function versus an array of 6 Booleans, right? It's a very different amount of memory that you have to index into to pull a value out, right? The block accessor of the world, I would imagine, is a pretty hefty beast. And getting a single block in a single position, like that's a huge amount of data that you're having to sift through versus 6 Booleans. So this is just a faster way of doing it and says, hey, only look at the sides that we have connections to. Right? That makes sense to me. So we should be able to possibly maybe put that here. And then possibly even here. Right? So, because we're already looking at the insertion sides and we're looking at the extraction sides, why not wait to look at the connection sides? Okay, so this now, remove single insert node. So now we want to, if we have an extraction side, we want to grab that node, remove insert node, right? We're just passing in which node we want to remove. Saying, hey, just remove this node. So now we come back up here, insertion side. So now we want to say, hey, we want to remove, so insert node, I think it's pipe insert node to remove equals new pipe insert node, but we want to pass it in. The most important thing is passing in what we're actually, like the neighbor block, right? which is up here, block position neighbor. So block position neighbor. Block facing is face dot op. Block facing towards. Yeah. Block facing dot opposite. Doesn't really matter in this instance, but string dot empty and then 0. We don't care about the distance. But we want to grab a new pipe insert node, neighbor dot copy. We want to make sure we do that. Anytime you deal with block positions, you want to do a dot copy. Okay. The block facing is, again, all we care about is specifically what the block position is of the neighbor that is now 0, because neighbor block ID equals 0, which means the get block neighbor, which is what we're passing in, is now it's now error. So we had a connection, we had an insert connection to it, but now it's error. So we need to remove it. I think I already have a check. Yeah, we are going to need a check to see if the position of the neighbor is loaded. If be helpers dot is chunk loaded neighbor, well, world neighbor. If not, return. Right? Because I would imagine when a chunk unloads, right, all of the blocks around that chunk may or may not get a neighbor block changed event. I don't know. That's a big question mark. I don't know. But if that neighbor unloads, right, the block the neighbor technically changes, but I don't know if that's a case of is the chunk unloaded. But if it is, if the neighbor block is unloaded, we don't care. We don't want to do anything permanent. We don't want to change anything permanent. Just ignore if it's unloaded. So with this pipe insert node, now we remove it from this block. That's important. So we remove insert sides, and now we remove single insert node, pass in the world from position, I think is us, and then insert node to remove is that. Well, we want to do that after we actually remove the node, right? We remove the insert node, we remove the insert side, right? So we take that away. Then we remove single insert node, right? Remove a single insert node to remove, or remove a single insert node to remove from a pipe system start at from position. So this should then go in and say, hey, all we're doing is removing one little insert node. So go ahead and just iterate through, update all of your extraction nodes, right? And then the extraction nodes are just like, we have things to deal with. So this takes care of another use case, right? Breaking a block next to a pipe. Whether that's an extraction node, an insert node, or another pipe, which is connected side. right? That's what this takes care of. Or if we can connect to it, which is up here, right? Which means you added something. Can connect to means, hey, the change that you just made, I can connect to it. So this is like an additive edge case or a use case. And then this neighbor block is pipe blaze new. This is, again, additive because you add a pipe. Our neighbor change is another pipe. Let's check to see if we can connect to it. And then the rest, this one here is removing, right? It's not additive, it's removal, which is I'm removing something from the next. My neighbor is changed and it's gone. So there is a case. No, it should be right. I was just thinking like what happens if a block is swapped really fast and it's like, but you don't. Doesn't matter. You're gonna break a block. Let's say it's dirt and you have a dirt block and you break it and then you put a chest. Well, that's two events, two neighbor block change events. One, when you break the block, right? It's not dirt anymore, it's air. So if it's air, we weren't connected to it anyway. So none of these trigger. It wasn't a connection, it wasn't an extraction, and it wasn't an insertion. None of those trigger, it doesn't matter. It doesn't do anything. Right? But then when you place a chest, well, that triggers this. Can connect to, I can connect to it, right? If it's an item pipe, I can connect to it. And so if this is true, right, if you can connect to it, then it's, hey, there's a new insert node, add the insert node. I didn't set insert sides face equals true. Right? So num insert connections, there's the new node. Right? We're creating a list and we're quick updating the graph, which iterates through and adds the new node to all the extracts. Yeah, I felt the legs. Yeah. The subtle little tail against the leg as she walks by. She's been about an hour off since the time change. It's been funny. She hasn't updated her clocks yet, right? Her kitty wristwatch. So yeah, there's probably little teeny bugs that I catch when I do like my edge case testing and stuff. Which is why most of my test worlds are just corrupted because so many like block entities and stuff get corrupted because it's like little edge cases that I run into that, you know, if a block entity isn't cleaned up properly or, you know, something like that, it's just I end up having to roll a new test world because of that. But just be glad I do that and I don't have everybody else have to do that because yeah, I try to catch as many bugs as I can before I ship something. So okay. Insert sides, insert nodes that remove, and I need num insert connections minus. Num extraction connections. Yeah, okay. Make sure all of the stuff and things are good to go. Then if I get can connect to, I need to do shape dirty equals true. Shape dirty equals true. Shape dirties are all true. Now I need to do a pipe neighbor changed. If shape dirty, mark dirty true. This is the base game mark dirty. Okay. This redraws it on the client, right? When I call this and true, not really 100% true. Yeah, redraw on client, right? So what this does is it resyncs the data to the client, and the client gets that, right? Because my number connections changed, something changed structurally, right? That's the important thing. Something about the block changed structurally. One of the connections changed, which means I have to rebuild that shape. The shape is going to be different from what it is default. And so the mark dirty true, when the shape is dirty itself, right, that tells the client, hey, redraw this thing. Because some of my connections changed. Now, I don't know if I actually sync the shape dirty event, but I certainly sync all of the sidedness. So this was that call that I did down here where I'm actually caching, right, some of the changes. Now, I could just say, hey, if API blah blah blah, right? If this is true, then just shape dirty equals true. Rebuild the shape. But the problem with that is this would be called, and the shape dirty, it would rebuild the shape constantly. Like every one of these calls, it would mark the shape dirty, which is not what we want. We only want to mark the shape dirty if our connections actually change, right? If our structure is changed in any way, we want to change it. Tree equals get int push cons. I don't know where these push cons come from. Num extraction. Oh, num insertion. Okay. Push cons and tick handler. There's tick handler. That's an integer, number of push connections. So push cons is extraction size. So int push cons equals 0 if extraction size of f meant to do that up here. For each pipe extraction node, blah blah blah. When we're in here, we need to do push cons equals e node dot insert nodes dot count, right? So just doesn't matter how many extraction nodes, the number will be the same, right? Just give me the count of the insertion nodes and come down here. If tick handlers is not equal null, tree dot set int push cons. I don't care, like, so this grabs num push cons debug. Because when I'm in the client and I'm trying to debug this stuff, I need the values to be pushed to the client in order to actually see them in the game, right? So that little that little thing at the top of the screen that has all the variables in it, I have to push those to the client in order to see those, right? The server, like a lot of the server side stuff, I don't need to send to the client. The client doesn't care. But in order to see those values to very quickly debug stuff, I have to send those to the client, right? I don't have super duper robust debugging tools built into the mod, which would be awesome to have those and spend time doing those, but those aren't fun. And most people don't care about those, right? Most people don't care about those features. They never use them. And so it's a lot less headline grabbing when you include major debug overhaul features, and it's like nobody cares about those. So I just haven't been able to justify the amount of time that it takes to, because my thought was like, for like debugging like the power network, right? Have like a tablet that you build in the game, like a debug tablet that you right click a power node, right? You right click the power node with the tablet and it just it loads all of the relevant information in a UI of the electrical system, like the whole enchilada, which you can then go through and look at. But the amount of work that it would take to do that is 60 hours, right? 60 to 100 hours is what it would take to do something like that. Crazy amount of time. Yeah, I know it's time for treats. It's treat time. It is treat time. Okay, so shape dirty true, yes. If these are changed, right? I should just give it the shape dirty attribute. I should just be like, push the shape dirty attribute. Like, what are we doing here? Yeah, I should just do that. Okay. At least there won't be a issue with that. It's just a lot easier to just glance at an extraction node and see how many push connections it has, right? Because on testing setups, I know how many insertion nodes there are on the network. I should be able to look at it and say, if there's 3 insertion nodes, look at the block and be like, oh, this has 3 push connections, which is right. Or if it's wrong, then there's something wrong. But at least I'll know that at a glance. And that data is coming right from the data it's getting from the server. So, okay. So this is, we're almost there. We're almost at the finish line of this whole process. The last crazy, we can get rid of these. I don't think we need these anymore. The last major thing that we need, and we're not going to do it today. Oh, here we go. We have the move extraction listener. Good. Remove extraction tick event. Extraction nodes of face index. Extraction nodes that contains key. That's good. Okay. I just want to. This is going to be so gnarly testing all of this. It's going to be so gnarly. The big one is this, right? This is the beast. This is going to be a beast. Right? It's doesn't look like much now, but it's going to be a crazy amount of work. Because we have on placed, where's on block broken? There it is. On block broken. Yeah, I know. Yeah, I want to be. So we call on block broken. So this to do crazy amount of work and logic. So this is like, we have to figure out a way to efficiently figure out when we break a block, right? When we break a pipe, we have to figure out how many connections it had, how many pipes that it was connected to, right? We don't care really. I mean, we care, but we don't care really about like insertion nodes and stuff like that. Well, like that's easy to clean up, right? If it had an extraction node, when we break it, that stuff is easy to clean up. The trick, the tough part is, did it have multiple pipe connections? That's the meat and potatoes of it. And of those other pipe connections, how many different networks are there? Right? So this position here on block broken, we are grabbing this. Why do we don't get the world identifier? Like, what is going on here? On block, called when the block is broken. Yeah. So this, right now, this just drops, right? It removes the extraction listeners. It on node removed of any extraction nodes. It disposes the mesh data, and it calls the base, which the base is, this is the thing that breaks the block, right? This is the thing that cleans up the blocking. This is the, and then the base is called after here as well. And this really does remove the block and clean up the block entity. This one probably doesn't do anything. This is a block entity base. It probably doesn't do anything. But basically, like this position that this is in, we need to figure out like all of the different positions of all of the different networks. And I have a sort of function that does that. I think we have one that merges, but where is split network? So this here, this is when you break a pipe, this is what splits the network around, right? But it's deceptively it's deceptively short, right? This split network is not. There's a lot going on behind the scenes here that I'm gonna have to figure out. Because right now this thing has, like, it removes pipes from the network, right? But then it's like, hey, how many connected pipes do I have? Yeah, and it's looking at network IDs again. We're kind of taking all of this away. But basically, what it's doing is iterating through all the connected pipes, and it's checking, like, are these pipes connected? So we have to do something very similar to this, but without the pre-known list of pipe locations. So yeah, but the Cant is insisting now that it's treat time, and yeah, so time to go. So yeah, thank you for coming by, everybody who typed in chat, very much appreciated. All of the interactions I love. And any questions you have, again, on these dev streams, like any questions you may have, is just, it's all welcome. I will try my best to answer any development questions that somebody has. I don't know everything, but I'm fairly familiar with not only this game but modding many games. So I've got skills in that. So anyway, thank you all for coming by. Hope you have a great rest of the week. Stay warm, and hope to see everybody back here on Saturday. Where we're going to continue whatever shenanigans we're going to be doing. So yeah, see everybody, and hope everybody has a great rest of the week.